to go through and just be like, hey, I know this area within my image is wrong. Let's just see what happens if I try and define it all as functions and code. And so this one does use processor-specific regular expressions to say, this is the prologue I'm looking for, this is the epilogue I'm looking for, to do a little bit smarter, and so that you don't just get everything forced as such. And the last one is make strings. When you see a block of area that you're like, this is all strings, don't want to go through again on your own, doing A, trying to do it manually, you can just say, hey, look for ASCII, they should all be at least this long in length, they have these characters, they should end with one of these characters, so let's go ahead and define anything you find that matches those requirements. So you will not use all of these every time you open a firmware image. You still have to use that knowledge of what you're looking at in the architecture to work. It's not like a fully automated framework. For example, define data as types would not work on any of the Renaissance Super H architectures, because in that one, all of their data is just under each function. So you're not going to have that giant block to be like, this is data and this is code. So you still do need to have that little bit of awareness within there. So let's look at this one. This is, I believe, the OTML. And so we are going to just run through how do we run that define code and function script within here. So you go to File, Script, select your script, put in the beginning and ending address, which for me, I just looked at when did it turn to all Fs at the end of the image and said between those boundaries. And now we have, what, 141 functions defined for us that we can start working off of and start our understanding of. Oh, I'm moving quickly. But what is this processor agnostic structure? How do we do this? How do we continue writing and building tools that aren't specific to syntax and the actual chips we're looking at? So the first way that I went about thinking this is all of these came out of the fact that I was writing the same scripts over and over again, but for specific syntax. I was like, okay, I'm looking at C166 now. I can't use my 8051 scripts, gotta switch over. So taking a step back instead and thinking about what in general am I trying to do? Then now what is that smallest piece that has to be dependent on syntax? Is there ways that I can just look at what's around me, look at the structure, abstract out certain pieces, so I really only need maybe one or two regular expression lines that have to be specific to each architecture going through. And so thanks to Tamir Bahar, he was the one who pointed me in the direction of this IDA-Python API call, which gets its get structure will return the IDA information structure associated with your database. In there they have a processor name, variable. It is valuable though too. And so by using that, the script will automatically look up which processor you're running on. It will check if you have put in regular expressions for that processor, and then it will just automatically take them and run with it. Before, I have presented a shorter talk of this at Recon in June when I first put together all these scripts, and the user had to go in and comment in and comment out based on their knowledge of the processor. So it's really great, and I appreciated his contribution in making that automated. That being said, when you look at the scripts, I don't have every processor in there because I just add to it when I'm working on each architecture. So if you take it, if you know that you always work with this specific processor, I'd greatly appreciate it if you'd contribute those one or two lines of regular expressions in there. But so what does this look like? I don't know if that's big enough for y'all to read, so I'll try here. But this is the starting point of the code for that define code functions we just ran. So as you can see at the top, that is where we get the processor name. Then what I've added in here in the processors I have supported thus far are 8051, PIC-18, Mitsubishi M32R, Texas Instruments TMS 32028, and AVR. So really, that's all you gotta add. A lot of these don't have a specific prologue, so that's where you use the sort of default regular expression and then just try and figure out which instructions do you generally see as the epilogue, the last instruction, and just put a regular expression in that. If you are more comfortable with strings other than regular expressions, obviously that is a way you can do that too. We got a nice green look now. It's hacked. No. So moving on to analysis. We've got our database, it's all triage, we know this is code, we know this is data, this is strings, this is RAM, this is where our SFRs live, what now? So one of the key points that I was always felt like I was spending so much time in banging my head against my computer was understanding how these functions were interacting, reading, writing memory. And that comes back to what we originally talked about. So let's use 8051 as an example. Since 8051 is a Harvard architecture, to access any memory on the memory bus, they have to use the D pointer. So that memory address is loaded into D pointer, then they do moves, and that's when you can read or write to that address. That means that IDA does not know that you are interacting with that memory address. They cannot create cross-references based on that because all you're doing is moving immediate number into the register D pointer. So how can we see that this function over here, oh yeah, and this one are all interacting with these same groups of memory addresses? So that's where find memory access or find mem accesses comes into play. What it's going to do for you is it's going to look for that regular expression. For us on 8051, it's move D pointer, and then it's going to look at what that immediate address is. It is going to then create the cross-references using the add deref instruction back and forth. So now, let's say you're at a function, you see that it's interacting with that memory address, you double-click on it to see where it goes, if it's already set value or if it's, read-writable, and now you can just do Control-X and see who else is talking with this. Who else cares about this value or who else is writing? And that saves so much time and energy. On another point, though, we also see a lot in these architectures of indirect memory offset accesses. And what that really means, we're getting a whole rainbow of colors. What this really means is that, say for example, on the one that I have at the bottom of this slide, if it's readable at all, is Mitsubishi M32R architecture, which is now you'll find on the Renaissance website since they acquired them, is what they did in this code, since they want it to be adaptable for different versions of hardware, board support packages, etc., is that at the very beginning of the code, they set the frame pointer to an address that's going to be, this is the block of memory this set of code is going to work off of. For others, they just have different places in the image so that they can use different values for calculations, timing, things like that. So everywhere in the code, I kept seeing things like this load or put the value that is at the frame pointer plus hex 4114 into register 1. That really doesn't help me very much as I'm trying to do anything. I had to, so that it turns out the value of this frame pointer was 80800, something like that. So it's not easy math to do in your head to just very clearly see it. And then you also see things such as these add 3 instructions where they are loading a register with that memory address to then access later on. So what this script will do for you is it goes through, it looks for that regular expression that for here I defined it as, an offset memory access using frame pointer, or the add 3 instruction using the frame pointer. And it's going to then first find all of those places for you. Then it will do that calculation of what is the actual memory address. So adding that value of frame pointer to the offset. Then it's going to replace the operand in that instruction so you can just see very clearly what memory address you're actually working with, which by doing that exact syntax, that makes it clickable and everything like that. And then it will create the data references back and forth. And suddenly you know, so for Mitsubishi M32R, all of their special function registers and ports are memory mapped. So now suddenly I know that, this value at port A is now being read and written by these different functions. And oh look, it's not only one that can set the value that is ultimately controlling this pump system. This one over here is the error case. And maybe I wouldn't have found that before if I wasn't able to say, oh, this is everyone that's interacting with that pin. And that's really helps with all of this time and things like that. And so one other aspect of this is that, thanks for the hydration. So another key point of this is that in a lot of these different things, you're working across segments or external memory and things like that. So how are these addressable? And I haven't added it in yet because I'm still trying to come up with a way that I think would be best to make this processor agnostic. But let's say in C166, they only use the 14 bits of the address. The top two say which page you're going to be in, and then you do the calculations and add it. So I've been able to do that for specific databases, but trying and using the majority of this code to do all of that, but trying to work and think about how to make that processor agnostic to help you see when you're working with things like PIC and C166 that have these page pointers throughout. So this is what it looks like. This is my M32R database, and this is going to be really terrible for y'all to look at on the red. And we're going to run this script and watch it change all of these instructions, like watch these two. Do y'all see my cursor at all? Yeah. So these two instructions, for example, are places that you will see changed and altered by this script. And all we got to do is we go up to File, select Script File, select Data Offset Calc, and we're going to put our beginning and ending addresses. I just used it where there was code and looking at where all those F's and zeros are. And then it runs through changing and creating all the data cross references. So now I can just click on it, press Control X, and see who else interacts with that database. And say, hey, actually I want to go to this next subroutine and see what they're doing with it. And I can then jump to the next one and see what else. And maybe one of those I've already done analysis on to help me understand maybe the purpose behind it. And you can go through, go to the memory address, have all of your data cross-references throughout, whether it was an add3 or the actual indirect offset in a load. So what does this look like? How do you actually do this? If you've probably heard, and I probably didn't help with my talk about the IDA 7.0, but a lot of people stay away from IDA Python because it is not easy to understand the docs, and there isn't a lot of documentation on it. But the reality is that the majority of all the code written is general Python. The only time you need to pull out one of those IDA Python specific calls is when you're actually interacting with the database. And thankfully, that can be pretty simple. So every script, I think there's 8 now in the IDA Python Embedded Toolkit, is less than, I think most are less than 40 lines. I think every single one is less than 100 lines. So it's not a lot of code going through there. This is every IDA Python call in that data offset calc right here. So the rest of it, the majority of it, is regular old Python. And so when you're looking at those IDA Python docs, what I need is I need to get information, and then I want to set stuff. So to start, the very first thing I got to do is I need to go and find those operands to see if it matches my regular expression to be like, ding, 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 here's your indirect offset memory access. Let's go ahead and change that and process that. So we use the get operand command here. And that one just tells us which operand we want from that instruction. Then, if, say, we've run our regular expression code, it matches, we know that we have an offset in there, and we just did some processing to find out what that offset is, we just move on to checking if it's negative or positive so we can actually do the calculation. And so that's what we do in the minus, or the if else statement right here. And then this op-alt is how we actually change the operand and how it's being displayed. So we can get rid of how the rest of the instruction says, you know, the at, the offset, comma, FP. We just say, here's your memory address, take it, I don't need to look at the other stuff. Then we just use add deref to create that new data cross-reference. So from the address we're at to the new memory address we calculated, and then it takes a type, which I just use DRT, meaning text, because otherwise we would have to get into more processor-specific stuff to understand whether it's a read or a write. And hey, for me right now, all it matters is that I can see them. By looking at it, I was able to see the reads or write. But if you want to add that in, hey, I'll take it. So the next step we take is we're going to create a comment if we wanted to, instead of replacing the actual operand. And we do it with the same syntax as how IDA would usually display it, so it's clickable and they know that to take you to that memory address. And finally, the only other IDA Python call we need in this whole script is next head, which gets us the next address we want to start looking at and processing as we run through the data range we inputted. So as you can see, you really can do a lot based on your previous Python knowledge without having to get into the IDA-specific API calls. So finally, we got through some analysis. What do we do with annotate? How can this help us a little bit? One of the key things that sounds super simple, what's really helpful, is a script that will run through your whole code base and check whether or not functions have cross-references to them. So no, this will not work for any architectures that do a lot of indirect function calling, but for others that really don't have that capability built into their instruction set, you suddenly know if there are blocks of functions that are used for maybe legacy code, another board. Maybe they have code that's developer only built in, and it just helps you really highlight and understand what you're looking at. So what this does, it runs through the whole thing, finding any code with cross-references, then it iterates through those, going down. So let's say you found a function that has no cross-references that calls 4 other functions. Of the 3, that's the only place they're not called, so meaning those could never be called either. It keeps working down the chain. So you don't spend time, wasn't me, that probably was me. Damn computers, who needs them? Oh, that was me then.
Is it back up?
There. Thank you. So let's. Oh.
It looks like it's up. Your phone, or your phone?
Yep.
There. That should keep it from sliding. I think that's what the problem was.
Okay. Thank you. Thank you very much. So yeah. So you can now know what's dead code, or possibly dead code or not, goes through. It can both write it to a file for you so you can parse that if interested, but also for me, I just, in this script, it will by default add a prefix to each function name that just says no cross-refs. So then as you're looking at a function list, you can just be like, cool, these don't have function cross-refs, I'm not going to be pulled into a rabbit hole down there unless I really mean for that to happen. The next one really gets into what we talked about of we really just care a lot about how they're controlling and sensing GPIOs. So they use the regular expressions for each architecture of how does IDA display those special function registers or ports whenever they're interacting with them. Searches for those in function codes in your instructions. One will list them in a CSV file, so if you like to do processing and understanding that way, but it will also, if you would like, it gives you the option as it runs in a dialog, prefix each function with just that port number that it's interacting with. So we'll see it in the demo, but that really helps to understand and be like, cool, this is the one that's actually reading and writing this port right here. Yeah, and then identify operand locations. I added that one in by just a request via Twitter from someone who wanted to just track on some architectures that have the stack pointer and the frame pointer just being used within the function. How can they quickly see each of those places? So this script in general will just search operand locations for you within the address range that you give it, and you just put in whatever regular expression you're looking for. So really just sort of a search type of thing if you're not wanting to use IDA's built-in search capabilities. Oh, this is the wrong one. Oh, there it is. So this is every IDA function that the whole toolkit had to use. So this gets back to it that the fact that it's IDA lack of docs, shouldn't be something that's scary. That being said, these all are for 6.9.5, and I think almost every single one of them has now changed in 7.0. So the point of the slide kind of has changed a little bit. But I'm planning, when I was trying to learn IDA and how to leverage it for my needs, what I really focused on was just where are the gets and where are the sets. And in their toolkit, they generally use the word make for anything that's a setter. And so when you focus on those pieces, it's much, much easier not to get bogged down in all the other calls that people use for more robust plugins and interacting with the full IDA toolkit. Because we really are just processing a lot of that textual disassembly representation to us to be able to help make our needs much easier. And so in 6.9.5, when you go to the IDA docs, you'll see, I'm probably just making up this number totally, but it feels like it's like 40 or 50 modules listed there for you to start looking at functions in. All of these, except for the 3 that have asterisks on them, were found in the IDC module. So you really don't have to get pulled into everything. Just start your search for what you're looking for at IDC, and then you can move up from there. But so what's next? I'm going to continue adding things. There are more features. I've written a script that will look for and process interactions or configuring and controlling different peripheral modules like I2C or UARTs, you know, all those different types of peripherals. It kind of broke with the update, so I'm working on getting that fixed enough and tested again. And so I think there's more of these triage processes we can automate, build in together so it doesn't have to have so much user interaction. I think it would be good to have more understanding scripting associated with different segments that are built in, especially when, you know, there's sometimes for different processor modules people have built into IDA. They do RAM over here, they do SFRs over here, they split the ROM up into different ways. So how can you understand that in a processor agnostic way? Oh, check, we did do automate architecture selection for scripts. The one thing I'm still working on is how do you understand which device of the processor you're trying to do. Currently, I have one of those choosers that you have to select it again, say for 8051, is it C515 or 80C52 or something like that, because those do show your special function registers differently. So I've been trying to work through a way to automate that piece of it. And just other manners to display information, because we all sort of are very particular, is a nice way to put it, about how our databases work, show information, things like that. So what other options and cool ways can we come up with? But really my whole goal here is that, you know, there's so many tools and processes and brainstorming going on and creativity that's happened on the x86, you know, ARM application and malware reversing community. How do we continue building that up for these microcontrollers and microprocessors as, say, adversaries move into doing more exploitation over there, and we just have to keep getting faster and more adaptable and more flexible. So hey, it'd be really cool if someone wanted to come up with a whole automated framework that I can sit in and listen to next year. But with that, I'm going to switch over to a demo. if I can figure out how to get it up on the screen. Let's see. Hold on. Where is this? Computers. That's the wrong button. So we'll see how this looks on the screen. But I have this just straight read off of a PIC 18 chip. It was read off of, via a debugging to get it off, and now we have the binary blob, but this time in a hex file, but still binary blob. So what do we do now? When we load this into IDA, let's see what we get. And where did I put my notes? So we have our hex format. We're going to go to microchip PIC 18C. This is what I mean when I said that we haven't automated the device name yet, but for this one, it's 4525-ish. And, oh, that's terrible. Let me see. Tried to make it big to see if that would help with reading, but okay. And then let me zoom in so y'all can see what this knows on the top of the screen. Oops. So that's a little too zoomed in. So what we can see is it was able to define a couple different segments as shown by these black bars at the top. We have a lot of code that it says is code, but it doesn't quite know. The blue, oh, that's Joy. Oh, that is cut off, okay. Thank you, because I would have just kept talking for myself. That didn't work, hold on. Okay, well, so trust me that the top bar tells you that there's some code, there's some undefined stuff in there, all sorts of good things. So what I'm just gonna do, since it's just sort of broken up, it found some function somewhere, it doesn't, I know that based on going through hex view, right here on this border, that's where it starts with a whole string of Fs. So to just try it out, I'm going to run the define code and function script just to see if it just couldn't find the entry point and so didn't get everything at the start. So what I do is I put my starting address, I just want it to start at the beginning. Instead of going all the way to the end, I'm going to use that address that started this string of Fs, which is 6E44. And I'm going to go ahead and tell it to set everything as unknown first, and just so it doesn't get caught up in what it thinks might have been previous function boundaries, since I've done no analysis yet. And so as it runs through, it actually found and declared almost everything at that top bar as functions and code within there. But when I start at this top and start looking a little closer, say, at this function, what I see is that there's actually a large block of Fs within here. And this gets back to that being particular types of things with your database. And I don't like to have code blocks shown as code if they're actually not. So this is a case where I'll just go ahead and take the defined data as types piece of this and say, I just want that all to show as some word section. So that address is 0x1e going all the way to 0x2000, just so I don't have to look at a bunch of knobs. Because looking at Fs is so much better. So once we've got here, I really want to know, can I filter down some of these functions? So let's go ahead and see if there are any that this script says don't have any cross-references to them. So I'm going to grab the label function with no cross-refs function in there, which this function I didn't mention earlier. It also has a little list if you want to put a couple of function start addresses at the top. Because, for example, your reset loop is going to have no cross-references, but that's kind of the whole point and really needed to start everything throughout. So in order to be able to do that iterative process of working down the paths, you have to have the starting point. So I just put in here my reset vector address to ignore when declining cross-refs and to interrupt vectors. So when we run it, I'm just going to say start at the beginning, go to the end, and look, we now have 1, 2, 3, 4, 5, 6, 7, 10-ish. We'll go with that. Functions that they're saying have no cross-references. We don't need to worry about getting caught in any of those. Now the next thing to just sort of work and get through some analysis is I will run the identify port use locations. It's going to grab my regular expressions for me off the bat. Again, I can just go from beginning to end because it's looking for code anyways. And then it asks me for a place to where do I want to save a listing of that file that I create, all the addresses that use it. And would you like to append, I guess that should be pre-pinned, not append, but anyways, append a prefix to the beginning of the function. Yes, please. And now I can see right here, it's labeled it as 1, 2, 3, 4 functions are interacting with port B. Let's see if we can find it. I could also look up. That's a bigger function. Oh, that's a really big function. So I might not find it in there. But, so the same thing that's written, oh, where? Here is, this also lists every single instruction for me if I wanted to then do some textual processing on that of here's the address, here's the types of instructions that are working off of these ports. So that's a little demo. Thank you all for getting up and out of bed super early, and do you have any questions? Go ahead. So I haven't run into that trouble yet. Oh, the question was, since using for finding prologues and epilogues, and you're based on the syntax versus the opcodes, have you run into trouble with that syntax being updated across processor modules? And I haven't yet because in reality I haven't seen processor modules updated that regularly, and that usually they're using pretty similar to the straight syntax of the instruction set. Are there any other questions? Well, cool. Thank you all for coming. I appreciate it. I'll be around if you want to talk more about this or reversing. Thanks. Oh, thank you. It's already up, and I'm going to continue to update it as I test things too. Yeah. Thanks. I am. Yes. Yes. Yes, because I work in a lot of different labs for each of my projects. So this is my, lab
Doing fine.
Need, audio outputs.
Not necessarily. What do you have for the projector? Is that all you have? I have an adapter for this one, and I got HDMI.
Do you have this?
No, but I got a VGA adapter.
Oh, you do? Okay.
Yeah, I went to the Apple store yesterday to get one, just just in case. Here we go. That's USB-C to VGA. So let's see. Should work. Do you know what the highest resolution is for these?
Not sure, man.
Okay, I'll see. Don't worry. We got some time. Bizarre. Dongle life. Here. Okay, let's see what happens. Apple, don't disappoint me. That's a good sign, I guess. Doesn't look too bad. My adapter wants an update. Okay. No, first row. Ah, beautiful. I'll take it.
You've been iced. That means you have to slam it. It's warm.
That's okay. I did worse things last night. Oh wait, is this on? Are we streaming yet?
Yes, we are.
Oh, good.
Just an FYI.
Mm-hmm.
It's about a minute or two. So when you're ready, you let me know, and I'll give you a signal that I've got the recording started.
Okay.
You can go. Okay.
Okay. Sounds good.
Yep. Any other questions?
No, I think we're good. This one works.
Okay.
Looks like it looks good. So wait 2 or 3 more minutes, and then I'll give you a sign. You give me a sign, and I'll start.
Yep.
Sounds good. Thank you.
We need to make sure you're ready most of all.
Yeah.
Then I'll kick it off so you can get the recording and not just the live stream.
Cool. Sounds good. Thank you. Yeah, it doesn't say how much percent it has. No. I don't know. Oh, it says Smirnoff. Yeah, probably is. You have a coffee there. Want a little shot in it? Want to spike it up? Yeah, it doesn't say what this is. Okay, doors are closed. I think we can start. Can everybody hear me? If I'm not sure how loud this actually is. It sounds loud. Very good, cool. Thanks everyone for coming in on a Sunday morning. That's really cool, really appreciate it. Good to see a bunch of friends in here, and everyone else obviously too. If I sound a little funny, this might be a German accent or the karaoke party last night, which was a lot of fun. I hope you all made it there. I'm going to talk today about DFIR and IDS for Wi-Fi networks. So DFIR, Digital Forensics and Incident Response, and IDS, Intrusion Detection. This is the first time I'm talking about a Wi-Fi topic. I spent a lot of time working on this, and I spent a lot of time in the whole Wi-Fi space in this summer. I think it's the spirit of this conference too, that I would love to get your feedback, not only on the talk itself, but also on everything that you're seeing, because I think we're all coming here to discuss things. So, because I'm showing this for the first time to such a broad audience, and I'm also releasing an open source tool today, I would love to get your very honest feedback after this, because as I said, I'm also still kind of new to the Wi-Fi space, so you might have a lot of input. So I'm leaving a lot of space for Q&A today. And yeah, I hope we'll have a discussion either during the talk. I'll be around until tomorrow afternoon. I hear there's some kind of beer fest today in town, so I guess there's a lot of opportunity to, to talk for the rest of the day. A few things about me. My name is Leonard Koopmann, 29 years old. Before I kind of stumbled into the security space, I was a software architect and software developer. I started the Greylock open source project in 2009. I don't know if if any one of you heard about that before. It's a log management tool, open source, specifically or very much focused on security and very much built for logs. So I guess you all would like that. This talk today, however, is not about Greylock. I'll use it because I'm obviously very familiar with the tool, and because this other open source thing that I'm releasing today is actually writing into Greylock, but you could use any other log management tool for this probably too. So I don't want to make this an awkward vendor talk or something. I was born and raised in Germany, moved to the US in 2015, and if you want to follow me on Twitter, this is where I spend a lot of time over the day. You can do that. It's @_ then my first name, or you can also subscribe to my blog, which is at wtf.horse, which was the best drunk domain purchase of my life, I think. It's a premium domain. They charge you like $90 for that. So it was still a good idea, I think. And you always have to put an HTTPS in front because no one will know that this is an internet address. But not the smartest marketing idea, probably. So I moved from up there on the right in northern Germany, where it's very cold and never warm and never really cold, so you only got kind of the autumn vibe all day long, to Houston, where it's very wet this summer especially, and also very humid. So I moved from this place to this place. No, it's actually pretty beautiful. I love Houston, you should all come. Okay, the agenda for today. I want to give you a really, really short intro to Wi-Fi security in general, and then spend a little time looking at the 802.11 specification and protocol, and specifically what management frames are, because that is important for the whole, not only IDS, but also the DFIR part for Wi-Fi's. I want to explain a few of the common attacks, so you probably all heard about, for example, rogue access points, evil twin attacks. So I want to show you some of those and also explain how you can detect those. So, for example, there is a very good open source Wi-Fi intrusion detection tool called Kismet. So if you look at their code, for example, you can actually see how they detect certain stuff. They have pretty good documentation explaining all of this. So I want to go over a few of these things. Then I want to show you my new tool, which I called Enzyme. I had a very good discussion last year with people in New York City who run kind of a lab co-working space, which is interesting. They're all in biology and DNA and stuff like that. And we were talking about is there any similarities between cybersecurity or information security and how the human body works and how the human body reacts if it finds viruses or bacteria, for example. So somehow I ended up with the name Enzyme. This is an open source tool. I'm going to talk more about this. And then give you actually a few examples. This is going to be a live demo, so let's hope this actually works. If it doesn't, I have some screenshots prepared, because I did live demos before and sometimes they simply don't work. So we have a fallback for that. And then, like I said, we have a lot of time for Q&A today, because I would anticipate that there's going to be a bunch of questions. I would really love that. So, short introduction to Wi-Fi security. I always knew before I spent more time with this that it's probably kind of insecure to be in a Wi-Fi in general. It is a total mess. The more time you spend with it, it's just you want to put wires in your house everywhere and just rip the card out of your MacBook. Attacks are pretty hard to detect and also very hard to mitigate, simply because the attacker could be sitting in the parking lot. So it's something that gets directly into your local network, but still you can be far away. So this doesn't have to be someone who has a network cable with them and just plugs it in the wall somewhere. It could be sitting in the parking lot and attacking your network. And another problem is that Wi-Fi today is extremely popular. I mean, light bulbs have Wi-Fi today. Every phone has Wi-Fi. Every computer has Wi-Fi. My mom uses Wi-Fi and just thinks that's the internet. This is how consumers think about that, right? And that's okay. But the problem is they don't understand the risks and the attack surface of this. So attacking is also very cheap, and I would say it's commoditized by now. Probably a bunch of people walking around here with little Wi-Fi pineapples that make attacking a Wi-Fi so easy if you understand a little bit about it. This is actually how I got into it, because everyone had one, so I thought I'm going to buy one and just look at it and got interested in it. And it's just so easy and it's so cheap. I mean, you get what does a Wi-Fi pineapple nano cost today? Like $100 or something off the internet. You have it 2 days later. So it's really easy to attack and it's really cheap to attack. Yeah, this is, I mean, they sell them with these little tactical packs, and you can just strap them on your belt and walk around with it. This is the Wi-Fi Pineapple. It's basically a complete attack platform that has multiple Wi-Fi chips in it. Comes with a nice little web interface that you can open on your phone, has a management access point, and you can just click around a little and you'll start certain Wi-Fi attacks. That one really opened my eyes. So, the Wi-Fi standard is 802.11. I learned that it's abbreviated as just .11. That helps. There's 17 different versions. So you'll probably see when you buy a Wi-Fi adapter online, you'll see that it's an 802.11a, B, G, N. What I learned is, and that's actually different, that's very important, the different versions don't actually define big differences in the standard itself. This is mostly about different frequencies, bandwidth, modulation, and by that data rates. So one of them, for example, open up the 5 gigahertz license-free frequencies. So 802.11 is usually 802.11. It doesn't really matter what kind of letter is behind it. So that makes it easier already. So we can just talk about 802.11 in general. That protocol is also defining frequencies and channels, because whoever wrote this figured out pretty early, oh, this probably got a lot of people are going to use this, so we have to spread this out over multiple channels and multiple frequencies. So for the 2.4 gigahertz band, for example, this is channel 1 to 14, where I think in North America it's really only channel 1 to 11, where the most popular channels are 1, 6, and 11 because they don't overlap with any other frequencies. So if you have a corporate network, so our office, for example, is in downtown Houston, where there's just a lot of noise. We have these weird antennas on the roof that mess with the network in itself already, you can see that there's a lot of noise on that frequency band already. So they come up with new and new frequencies to make more room for all the communication. Now that light bulbs and toasters and juice makers need these frequencies, you just need more frequencies, basically. And the MAC layer of the 802.11 standard defines 3 types of frames. A frame, I'm not following the terminology of 802.11 here very strictly, simply because they talk about stations and non-stations and all kinds of stuff. I simplify this a little. The standard itself is this thick. It's a lot of stuff in there for a bunch of functionality I've never seen before in any kind of Wi-Fi. But I'm going over the most important here. So there's 3 types of frames. There's management frames. This is what we'll be focusing on today. There's control frames. This is simply to assist in delivery with data frames, which is your actual data. So in your data frames, your emails, your websites, HTTP, TCP, everything is in those. However, to be able to join a Wi-Fi network, you have to do a whole dance with a bunch of management frames. This is if your computer or your phone decides to connect to a Wi-Fi network, then it's sending a bunch of management frames back and forth until it's authenticated and then able to send control and data frames. Control and data frames are interesting if you want to sniff data. We're not really focusing on that today. We're focusing about the attack surface of management frames. So every frame type, the important thing to understand if you want to learn more about Wi-Fi security is to understand the subtypes of the management frame type. So there is a bunch of them. We're going to go over them right now because this is really important for the IDS and the DFIR part. So the first frame type is called the authentication frame type. I put the abbreviation behind it. That's kind of a standard. It depends on what you look at. If you are, for example, if you're analyzing stuff with Wireshark, it might be a little different. I follow those of TCP-DUM and the official standard. So you'll see these abbreviations later in the demo a little more. The authentication frame is what your device sends as a first step when it wants to join a wireless network. So you're at Starbucks, you want to join their network, it sends an authentication frame, and being authenticated or not restricts the ability to send or to receive in a network. Again, you have to be authenticated to be able to send or receive any control or data frames. If you're not authenticated, then that stuff's simply going to be discarded. No one's going to look at it because you're not in the association table of the access point. The authentication process itself, and this is already where the standard gets a little interesting, I would say. It depends if you're connecting to a WEP or, for example, a WPA network, simply because it feels like the WPA encryption has kind of been bolted on the original 802.11 standard when everyone figured out, oh God, WEP is not at all secure. So if you see a WEP network somewhere, just do not use it. You can crack those so fast. I hope that's common knowledge by now. But This is different. I don't want to go too deep into that, but there's a different sequence of authentication and secrets and stuff being exchanged before you're authenticated. Then this is probably everyone's favorite frame. It's the deauthentication frame. You'll see that a lot either in an attack itself, and we're going to look at that in a second, or you'll see that as part of another attack. What this does, it's a simple unidirectional announcement from one station to another station. So for example, from the Hyatt access point to my iPhone, saying, hello, I would take you out of the association table. They act like you're not in here anymore, and your phone then has to decide if that should be followed or not. Usually your phone will do that, any device will do that. And basically, the access point just tells your phone to go away, I don't want you here anymore. The problem is, management frames are completely unencrypted and can be spoofed very, very easily. It's completely unencrypted frame, so if you have a Wi-Fi card that allows you to send any kind of packet, which is any card that supports packet injection, which you get for like $30 off of Amazon Prime, so if you order them now, you'll have them probably by tomorrow morning. That means that I could have a Raspberry Pi here that just sends a deauthentication frame, and your phone would follow it if I just pretend that the access point sent it, and that's just a field in the message. It's not encrypted, everyone can send that. Now, when I read this for the first time, I thought, well, to put this in the standard, that doesn't sound like a very good idea. But if you think about it, you actually need something like this, because it comes with a reason code, and there's, I think, 70 reason codes that are defined, and another, I think, at least 200 that are open for vendors to use. But a reason code could be, for example, your previous authentication is no longer valid. This is what happens when Hyatt decides you get the guest access for 6 hours, and then some cron jock kicks you out and says, nope, deauthenticated, you have to buy our pass now. A station has to be able to kick you out. The problem is that everything's unencrypted, and this, I think, was simply done to make it easy for consumers to connect to networks. Because if you had to exchange kind of a, because remember, the management frames are used to connect to the network at all, so there's no authentication yet at this point, so you would have to kind of exchange a pre-shared key and all of that. This would never work, especially not with a juice maker, I guess. So this is simply a fact, and this opens a huge attack surface. More about that in a second. Then there's the association request. This is the last step for joining a network. This is basically after you're authenticated, you say, okay, I would like to be associated with this access point now. Because you also have to remember there could be, like here in the Hyatt Wi-Fi, for example, there's probably 100 access points that serve the same network. So your phone decides which access point to actually connect to. This then allocates resources on the access point, synchronizes both stations. This is just part of the authentication, basically. It's the association response. This is simply the access point says, yep, you're allowed, I got you in my association table, all good. This also includes information about the supported data rates, because many chips today support a lot of different data rates. They could be on different data rates and different channels. All of this is done during the association request. So they basically agree on a format of communication when that happens. It's the reassociation request. This is when you walk down the hallway, your phone decides, wait, I'm much closer to this access point now, I should deauthenticate, or should disassociate from this one behind me that has a lower signal strength and reassociate to that one. Then these two will talk to each other and be like, no, he's authenticated here already, so I'll let him in here. All of this happens, this is a reassociation request. I don't see them very often. I honestly don't know why, but they are there, apparently. Same thing with the response. This is just the same thing where it says like, yep, you're in, you're authenticated, and you are associated with me now. This disassociation, this is when my phone says, nope, I don't want to be associated with you anymore. This is basically like a graceful shutdown. Imagine if you would just walk away without disassociating, then the access point would have to wait for a timeout to actually clear you out of the association table, because you might still be there, but they'll wait a few minutes and then be like, nah, he's probably gone, I'll kick you out. So this is just a nice way to do it. The standard says you should do it, but if you just walk away, it obviously doesn't happen. You just, poof, go away. This one is interesting. This is the beacon frame. The beacon frame is by far the most common frame type that's in the air here right now. This is access points basically announcing that they are there. They are like a beacon out there, and they say, hello, I'm here, this is my supported rates, this is the channel I'm operating on, this is my SSID, If you want to connect to me, I'm here. This is, if you click on your, on Windows, I think it's on the bottom right, on OS X it's on the top right. If you click on your little Wi-Fi icon, it shows you all the networks that are there. It says I'm scanning for networks. It's not actually scanning for anything. It's just waiting for beacon frames on all channels to come in. And then it just collects the SSIDs and tells you this is all of the access points that are in range. So it's really like the name. It is a beacon of access points that are out there. Then there's the probe request. That one has a lot of very interesting information. So the phones that are in this room here right now, if you have Wi-Fi enabled, they're probably sending tons of probe requests in this moment. This is basically, this is your phone asking the whole vicinity around you is a specific access point here, and it will answer with a probe response, which comes in a second. So if you're, for example, you're leaving your office, you're going home, then between that, you're in your car, you're in the train, whatever. Between that, your phone is probably not being connected to Wi-Fi. So it constantly tries to figure out, wait a second, maybe I'm close to home, so let me ask if I'm close to home. So it sends out a probe request that says, hello, home network, are you here? And then it listens for a probe response from the home network that says, yes, I am here. That is interesting because it's unencrypted. You can listen to all of that and you can build pretty interesting profiles of the phones that are around you because they'll show you your office network. In fact, my phone is sending this for our office network in Hamburg, where all of our engineers work, and for my home network in Hamburg, and for my home network in Houston, and for our office network in Houston. So you can build pretty interesting patterns, especially with these databases online, where you just enter an SSID and it shows you where this SSID has been seen. So there's stores now out there apparently that are using probe requests to identify phones in their stores to see how people are moving around. Because if you put enough sensors around that just read these probe requests, then you know, oh, this person that is constantly asking for this network was here on Saturday the last time, spent a lot of time at the milk aisle and is now at the egg aisle, for example. You could do that if you have 3 sensors. You can triangulate where these things are coming from. So your phones are doing that in this moment. It's a probe response. This is just an access point saying, yep, you asked for me, I'm here. So now there's common attacks, obviously. The most common one, and this is, I guess, what a lot of people played around with at least, is sniffing traffic from open or even encrypted networks. So if you are around an open network, like here I think the Hyatt network, you can go in and you can just sniff the traffic that's going on. So whenever you're on a Wi-Fi, you really either want to put a VPN over this, one that you trust obviously, or you want to make sure that everything you do is going through encrypted channels, so HTTPS. You should do that anyways, but just as a reminder, all of this stuff, this is not at all secured in any way if you're connected to an open network. It's really easy to read. I remember that a few years ago, someone came out with this Firefox extension, I think, or some kind of little tool that would just listen for the network traffic at an open Starbucks Wi-Fi, for example, or any other coffee shop, and then just give you Facebook logins. It would just show it to you. And this is, when this came out, people really started to enforce HTTPS. They came out with HSTS, all of these things to force people to use encrypted communication on a Wi-Fi simply because it's so unsecure. Now, what many people don't know is that they think, well, I'm in an encrypted network, might be a WPA2 pre-shared key network. The problem is that this can also be sniffed if you are in the network. So if you know the network's password, so you're in your office network, and obviously because you're an employee, you know the office network's password, then the connection between you and the access point is encrypted in a way that has been negotiated between you and the access point. So you have your own encrypted channel between these 2 stations. The problem is that if you sniff the authentication process, you get the whole key, so you can decrypt it again. So if you have the master key, which is the password you enter when you connect to the Wi-Fi, you can read the traffic of anyone else who's in the Wi-Fi too. There are certain attempts to block this now. There's all kinds of enterprise encryption stuff, but really most of the things you see out there, I guess, is WPA2 with a pre-shared key. Remember that if anyone else has the master password, very easy. There's a bunch of tools out there that will do that for you to still read the still read the communication of everyone else who's in that network. So that doesn't make, that does not give you security at all. So when you're in a Wi-Fi, always, always, always put this through a VPN or make very sure that you have encrypted channels. And there's some things out there that you just forget. For example, Git. If you use Git, that is usually unsecured. So if you don't use Git on GitHub through HTTPS, that can very, very easily be unencrypted. So there's all kinds of stuff you want to think about, and maybe just tunnel it through a VPN that you trust, which is a whole other talk, I guess. This attack, so sniffing traffic, pretty much impossible to detect because the way you do it is you just passively sniff the traffic and then you analyze the captured traffic and you just decrypt it. So it's basically impossible to detect because it's in the air anyways. You just have an antenna that picks it up and then you decrypt it offline. Another common attack is jamming. This is something that some people like to do at conferences for some weird reason I don't understand. But you can either do classic jamming, like just put garbage over the frequencies so nothing in the vicinity works on that frequency anymore, but that needs pretty special equipment. I think that also gets certain authorities pretty close to you pretty fast. The thing is, however, you can do that on a higher level of the protocol, which is deauthentication frames. There's little Arduino firmwares, for example, or Raspberry Pi Zero firmwares that will simply listen for all the MAC addresses that are connected to an access point, and will just blindly fire deauthentication frames around, so all these devices constantly disconnect. That works on tiny hardware. You just need an antenna. That's pretty much it if it has a Wi-Fi chip and it allows packet injection. This can, however, be detected by simply counting the number of deauthentication frames. If you have a histogram of how many deauthentication frames are in the air, you should be able to count that and find anomalies there. I'm going to show that in just a second. Then, this is, I guess, the most interesting one at least. This is rogue access points. So, what would stop me or anyone from just spinning up an access point, calls itself Hyatt Wi-Fi? You'll probably join it. If it's the closest to your phone or your device might actually pick it automatically because they tend to connect to the strongest signal strength. Now I got a man in the middle pretty much because everything goes through my device and I can do DNS poisoning, ARP poisoning. I can listen to all the traffic very easily. In fact, I don't even need to mess with all the stuff because it goes through my device anyways. So this is, I think this is the most severe attack that's out there, and this is also the most, I would say, popular attack during pen tests and any kind of red teaming. Because simply, it's so easy to trick devices to connect to something, because if you can spoof everything, you could even give it the same MAC address as the other thing. Who would know that this is a rogue access point and not a normal access point? There are, however, several ways to detect them, luckily. This is what Kismet is extremely good at. You'll be able to do the same thing with Enzyme and with Greylog, or you could just use the combination to respond to alerts that Kismet already gives you. It's up to you. So you can detect a rogue access point in several ways. You could, for example, do BSSID whitelisting. This is basically the MAC address of the access point, and you can say, my office has 25 MAC access points. That's 25 MAC addresses. Whenever I see a beacon or probe response or anything that advertises my SSID out there that has a different MAC address, then all alarms should go off, because that probably means that someone runs a not very sophisticated attack with simply just another access point that has the same SSID. Problem is, you can simply spoof that. You just walk around, record the MAC addresses of the existing access points, and just put that MAC address into your access point. Now it's really hard to detect it again, right? So this only protects you from very, very unsophisticated attacks. The good thing is there's other ways to detect it. A very interesting thing, I thought, is by detecting non-synchronized MAC timestamps. A MAC timestamp is a timestamp that is included in every beacon frame of an access point. So remember, this is the access point sending dozens of these every second, saying, I'm here, I'm here, I'm here. The other access points will listen to that, and they actually use these to synchronize each other. So because it's extremely important that all of the access points are synchronized up to, I think, I might be wrong, 25 microseconds or something, they have basically their own little version of NTP that goes directly over the air, and they synchronize each other through a timestamp that they broadcast in these beacons. And the thing is that a lot of people who will be a little more sophisticated and at least spoof a MAC address and run what's called an evil twin attack, they will probably not bother to synchronize these MAC timestamps. So you will have, you could analyze the MAC timestamp, and because it only increases, it's just a long that gets that increases and increases and increases. You will have steps in there in every beacon that comes from the wrong access point. So if you collect all of these beacons, and this is something that Enzyme is doing, then you can basically draw a chart over the value of the MAC timestamp that's in the air, and that should just linearly go up. If that thing does something funky, that means there's probably someone around here who spoofs an access point without synchronizing the MAC timestamp. Can also detect unusual channel or frequency usage. So if your corporate network always runs on channel 11, suddenly appears on channel 2, might be something interesting. The problem is to avoid contention and bandwidth issues. A lot of the vendors for the better access points are dynamically choosing the frequencies and channels now. So my home network, for example, is already jumping from channel 1 to 11 because my neighbors are already on channel 11, and when they get very active, then my access point switches to something else. So that doesn't really work anymore. It's also, this is the easiest to spoof probably. You just run your access point on the frequency that the others run on. Now you wouldn't be able to be detected anymore. A crypto drop could be that your network is usually WPA secured, and suddenly there's an access point that is not. That could also just be a very unsophisticated attacker. That would be something interesting to see. And then something else that I thought was very interesting is by analyzing the signal strength. If you look at, now imagine someone is spoofing the MAC address of an access point. An access point doesn't really move, right? It's mounted to the wall, it's sitting somewhere. If you draw a chart over these over the mean signal strength for every MAC address out there, if suddenly there's outliers in there again, if this thing starts to get a little funky, that probably means that someone with the same MAC address sits out there in the parking lot, or sits somewhere where the access point usually is not at, and you have a completely different signal strength. So this is another way to figure this out. The problem is that there's tools like Kismet, and they're great for detecting this kind of stuff. I really like that project. They also do a lot of Bluetooth stuff now, a lot of fun, open source, should definitely try it out. The problem is that you just get an alert, and it's really hard to respond to that alert, right? I mean, imagine you get an alert, hey, there's a rogue access point. So what you gonna do now? Shut down, pull the fire alarm? I mean, what you gonna do, right? So it would be great, I think, or you couldn't, I mean, the answer would be, okay, that was a targeted rogue access point attack. That wasn't just some kid walking around with a pineapple that just sends DOT frames all around. It was a targeted attack, someone tried to get in here. But I have no idea how to find out who connected to it. I want to find out who of my employees connected to that thing, right? That'd be great. I don't know for how long it was there necessarily, and I don't know where it was located physically. So basically, you just get very nervous, but you can't do that much about it. So Wireshark and TCP dump can collect all these frames. It's actually pretty easy. You just select the interface. You just select the interface of your Wi-Fi adapter and monitor mode. And it will just spit out all the 802.11 frames. It's very easy. The problem is that they really fall short on long-term collection and analysis. You'll probably run that for an hour, maybe a few minutes. Then you put it in Wireshark. You'll follow the little loading, this famous loading indicator on the bottom. It takes forever. Your computer starts to lock up. They're great, but they are not really there for long-term analysis. You wouldn't want to analyze 500 million frames out there with these tools. So that's where I stopped with my experience with Wi-Fi security, and took a step back and thought about, wait a second, I know about this tool that allows you to collect a lot of structured data and allows you to analyze it. Because if you think about it, really 802.11 frames, especially the management frames, that's kind of like a net flow stuff that comes from your router. Very high level information about what happened with a lot of meta information about who communicated with whom in what way, right? So I thought, wait, we have something like that. It's called Graylog. I'm kind of familiar with it. So I was on a vacation in Europe. I got bored after a few days, and I started writing something that reads these frames off the air, structures them, and writes them into a Graylog. And that's what I called Enzyme. Enzyme, together with Greylog, allows you to store this data for a very, very, very long time. I'm running it in my home lab with 2 Wi-Fi adapters that are hopping through all channels of the 2.4 and 5 gigahertz range. It's been running extremely stable. It runs on a Raspberry Pi. I'm running one in our office, actually, that's downtown Houston, on like 24th floor or something. That gets a lot of frames. That's on one Raspberry Pi 3 Model B, and it's probably a 25 to 30% CPU usage. So it's pretty fast, even though it's written in Java, which I'm just very familiar with. But you only run it on the sensor. You don't have to install any client. So Java's actually pretty cool. That's going to be another talk. And obviously, I made it open source. I think there might even be a red team use for it. I would love to hear your ideas. If that is something where you just walk around with that thing, use it kind of like a pineapple, but instead of the pineapple kind of little clumsy way of analyzing the logs, you have that directly in a tool like Greylog, where you can, after that, do a lot of very efficient recon maybe. I don't know. I have no clue about a red team. I saw this talk before here. I did not know what's going on. More on the blue team side, definitely. So it's open source, obviously. This is what it looks like. This is 3 of the stuff you see there in front is the network adapters. Then I'm running this there on a different machine. It's like you get them, it's like an Intel Atom chip, I think. They're a little faster. They simply allow you to draw more power from it. Raspberries start to kind of randomly shut down if you put more than 2 of these adapters on it. So I wanted to have 3, put a different machine on it, but the real one really runs on a Raspberry Pi. That's what it looks like. It really only needs 1 or more Wi-Fi adapters that support monitor mode. It runs on OS X for if you just want to quickly test it. And the reference kind of platform is a Raspberry Pi 3 because that's what I run it on. That's where you find it. I have not bought a domain yet because you know what happens when I buy domains. In fact, last night I was about to buy one and I luckily didn't because the karaoke party. So find it on GitHub. Maybe if people like it, I might put a domain in front of it. We'll see. This is just github.com, my full name /enzyme. If you follow me on Twitter, I'm going to post a link to that. There's actually 1 or 2 in there already. Or you go to wtf.horse. That has a link to that too. Hope that's easier to remember. Okay. So I would say I try to make the live demo gods happy and just try to show you what this looks like. This is a preloaded page. I don't know if it will reload. Oh, before we start, let's actually go to Enzyme here. I was late to the party last night because I finished the documentation and the README. So this has quite a lot of README. You should be able to just download it and start it. This should have everything in there. If you get stuck anywhere, please open an issue. You're literally the first people that see this, so maybe this doesn't make any sense, or maybe it's just really hard to install. Just know already it's Java. So all you need is, Raspberry Pi, you need a wireless network interface that supports monitor mode. I'm linking to those that I'm playing around with. Actually, you get them 1 for 30, 1 for 40 bucks off of Amazon. You probably have some lying around already. This is all abstracted on the operating system layer, so I don't care what you run it with. If it supports monitor mode, we'll be fine. You see here, the other thing that it needs is a Greylog cluster, obviously. This is just one machine running on an old HP server somewhere. You can, if you want to play around with it, if you haven't used it before, if you don't have a Greylog running, there's operating system packages for everything. There's an Amazon image, there's an OVA if you just want to spin it up quickly on a virtual machine. This shouldn't be the hard part. If you like it, you can still build a real cluster, but this shouldn't be the hard part, I think. So, let me show you what the data looks like. Oh my God, it's working. This is amazing. Okay, so this is also coming through. Oh, it's long. No, I'm going to skip that. It works. That's great. You see here, it's very familiar to, I think the usage of Greylog is very familiar to another log management tool out there that tends to be a little expensive at times. This is, by the way, if you go to GitHub, download Enzyme, you get all this data. If you go to GitHub, download Greylog, you get this thing. So it's all open source. Basically, you got your search bar up here, you got your messages up here, and you see, and I hope you can read that. for example, you see here that I received a beacon frame for the SSID Xfinity Wi-Fi on this frequency that equals channel 11. It's not WEP. It tells you which enzyme sensor got it. It gives you signal quality, signal strength. It tells you the SSID, the subtype, very important, and it tells you who sent it. So this basically tells me there is an access point with this MAC address, and it sent a beacon for this SSID. Now Greylog, like any other tool, allows you to, for example, say I want to search in the last 2 days. It's still working. You see here, this is how many frames came in. You see that in the last 2 days, I collected about 5 million management frames. Result came back in about 376 milliseconds. And now I could go in and say, show me the distribution of the field subtype. Some would call it a pivot table. We call it quick values. Click on it. Takes a little because of the story of the connection. I'm going to tell you later maybe. But you see that we get 75.53% of beacon frames, bunch of probe requests, bunch of probe responses, and some deauth frames. In fact, I think there is a neighbor who has a Raspberry Pi. If I show you this, so let's say I want to see all deauth frames of the last 2 days. Okay? Click on this button to say add to search query. I could also just type this in here and say subtype equals blah, blah, blah. But I just click on it to execute the search. I search for it. Now you see this is the distribution of deauth frames somewhere in North Houston over the last 2 days. You see we got a little spike here. So let's zoom into that. You see that this fills out a query for the time range that I just selected. I execute this thing. And you see that we got about 376 deauth frames here at 6:55 on Friday. And you see here, it tells me this transmitter tried to deauthenticate this station from this access point. It says unknown reason with a really weird code here. That is simply because I wrote the code wrong. This is not an attack. This is an issue already. This would give you a reason like the access point is leaving the station or your authentication expired, something like that. I just have to fix that. It's weird network protocols with short and byte order, and I got that wrong. Yeah, you see here, so now I might be interested in, say, this transmitter is deauthenticating stuff. So let's take the MAC address of the transmitter. I just copied that. Say again, I want to search in the last 2 days. And I'm just going to run a full text search for this MAC address and say, show me everything that this MAC address did in the last 2 days. Aha, here we go. So let's see what kind of frames this MAC address sent in the last 2 days. Okay, it sent a lot of beacons and then about 82 deauth frames. That's interesting. So let's say, show me everything from this MAC address that has the subtype beacon so I can see what kind of network is this device advertising, right? Now we got all the beacon frames. And it is mostly broadcast beacons, which is interesting. So let's go back and see if we find another device in here. Just 1 second. This is not what I wanted. Here we go. Live demo, don't disappoint me. Here we go. So let's take, what do we have here? Let's say we want to instead look at the destination, like what was deauthenticated, right? So I do the same thing. Go into the last 2 days, enter this. Here we go. This is the activity of this. Okay, now that's even more interesting. So again, go into the subtypes. And you see, haha, it sent deauth, it sent a bunch of probe responses, and it sent a bunch of probe requests. So let's see what networks this device asked for. And you'll see it's looking for a network called AT&T Wi-Fi. So you can now, with this kind of stuff, if you detected that there was a rogue access point, you could go in and say, show me all the authentication frames that went to this device, and run a pivot table over the transmitters of that, which is the devices that try to connect. Do that, and then you'll get a list of all the MAC addresses that connected to this very specific access point that might be a rogue access point. You can use the generate chart feature here to build this linear chart of the MAC timestamp, for example. You could use that to build the average signal quality of all of your access points that are out there. I am also using the lookup tables that are in Greylock that can be filled from any kind of API to, for example, get me a transmitter name, where I basically translate MAC addresses to known devices. So you see that this is my main access point at home, this is my extender at home. I don't know who Jane is, to be honest, but Jane's MacBook apparently sent a bunch of stuff. It's my Amazon Echo in the office, there's a Chromecast in the bedroom, so to make it easier to analyze all of this stuff, you can use the lookup tables to translate MAC addresses to names, for example. Now my favorite thing before we go, because we only got a few minutes left, I promised you more Q&A time, I'm sorry. My favorite thing is to go in and say, show me all the probe requests, which is in the last 2 days, that was about 296,000. Show me all the probe requests. And then give me the SSIDs that the devices asked for. There you go. This is my Sonos at home. This is going crazy a little. I don't know why, but you'll see there's a bunch of people asking for, this is AT&T networks. This, in fact, this is our network in Hamburg. That is about 8,500 kilometers away, but my phone asks for it. So this appears somewhere in North Houston now. You see everything here. The neighbor's car will appear in there. You can, with this stuff, if you wanted to, I'm very specifically not doing that, but if you wanted to, you could build patterns of when the neighbor goes to his car, if it's his wife or him, when the car leaves and when they come back, simply because the stupid Camaro is sending beacon frames that you can follow. You can even see how fast they drive away based on the signal strength. It's like, so this Wi-Fi stuff is crazy. It's a lot of fun to just send it in and just dig through it. So yeah, I open sourced this. I hope it's any value for anyone. And if you have any questions, you can fire out GitHub issues. You can connect me, follow me on Twitter. I'm around for the whole day until tomorrow night, actually. So if you run into me, I'm happy to talk about it. And I hope this was interesting. It's the first time I did it, so thank you very much. I think we've got 5 minutes left for questions. So if there's any questions out there? Yeah. Yeah. Yeah, so the question was, is there any way to configure these channel hopping frequencies, for example? Yes, you can do that. Here's an example config, in fact. You see here that it has a channel hop interval. That's simply, it's currently in seconds. I might expect that some people want to have that in milliseconds, for example. I can change that. It also has a beacon frame sampling rate. So if you say, I only want to record every 5th, every 20th beacon, simply because it's so much data, then you can do that too. Mm-hmm. That's an interesting idea. That's currently doesn't do that. If you could open an issue for that, that'd be great. That'd be interesting. If you can send data back to Enzyme to look at something very specifically, because right now you do channel hopping. I mean, basically, you all saw the famous Wi-Fi cactus, I think, with this guy with like hundreds of access points, hundreds of Wi-Fi cards on his back. This is because if you do channel hopping, because the Wi-Fi card always has to be tuned to one frequency. If you want to get all frequencies, you have to hop over these frequencies. If you want to narrow into a certain frequency in a certain device, for example, I think that was your question, right? Oh, okay. Even better. Yeah. Okay, sorry, then I misunderstood your question. The question then was, can enzyme, when I detect a rogue access point, and this means you understand the whole topic, can enzyme then fire deauth frames at the devices that are currently connected to it, right? To force them off the rogue access point. It currently can't do that, but that'd be interesting. Greylog has REST APIs, so you could have a Python script or something that just reads that from Greylog and then fires it off. That might be interesting. It's a very good question. Yeah. It currently only supports Greylog, but it sends a Gelf message, which is a Greylog message. Logstash, for example, supports that as an input. So if you want to write it somewhere else, sure. Mm-hmm. Thank you. Mm-hmm. Okay. Mm-hmm. Yeah. Cool, sounds good. By the way, if anyone finds a shop where you can get a Yagi antenna with a real, I forgot the name already, SPSMA something thing that works with a normal adapter, let me know. I still don't have one. For 3 months and a lot of different adapters, I got scammed on Newegg. It's a nightmare. You don't get these Yagi antennas anymore. If you find one, please let me know. Okay, cool, thank you very much.
Hear me okay? Whoa. I can hear me. So, hello everybody. Thank you for coming to the show. This is Going Deep and helping to empower our users. Again, thank you for coming. I'm Joseph Sigmund. For those of you who don't know me, I don't do a lot of talks at DerbyCon. As a matter of fact, this is my first one. Most of it, I just do local things. If you want to get a hold of me, there's some contact information that'll be up there again later. A little bit about me. I am a CISO for a large international retailer, although today is my day off, so I'm just representing me. I've been in IT for 25 plus years, and I've done security for probably 20 plus of that, to some capacity or another. I started a few companies of my own, and been doing that for a long time. I still have one today. And then I kind of have had a real job like most all of you. Wrote my first program when I was 8 or 9, and I've learned a few other languages in between then and now. It's not what I do with my day job, but it's what I love to do. So instead of watching sports and things like that, I sit at home code. I'm a dad. I try to be a loving husband, which are probably the most complicated things and tough things in my life ever. I love scuba diving. If you didn't notice the picture on the front, that was me sitting at about 85, 90 feet in the front of the Spiegel Grove, for those of you diving. I love things geeky. I love all things geeky. And with that being said, because this is pretty much all I do, a little bit of advice is, as you're kind of going through your journeys and whatever it is you're doing, as you're going through your career, my suggestion is to take a moment, stop, look for something to measure things, right? Certifications. So yes, I have 26 certifications. I just kind of got them a little bit here and there through the time, right? So as a CISO, I will tell you that that helps you through your career, and it will help you in the future. It helps us in communicating, and that's probably the most important piece here, is that if I come to you and talk to you and I say, hey, are you a network guy? You're like, yeah, I might ask, like, have you done your CCNA? You've done your Network Plus, things like that. It tells me where you stand, so I don't have to go back to like square one, right? So like, even I'll tell you, in getting ready for this talk, I have like way more slides than I'll ever get through in like 10 hours. But the point here is I start kind of basic and I kind of move on, and there's some more complicated things in there, so this will move a little quickly. I apologize, but I'm just trying to get the point across for a larger crowd. So take the time, try to invest in yourself. I know some of them are just there for paper and money-making schemes, but they do support you. You are that important. If you want to get a hold of me, again, here's my contact information, my GitHub. I'm on Twitter. I don't post much. If you know, the things I'm going to show you, I will have stuff out on GitHub later, not there today. So what are we going to do here today? One, we're going to go deep. We're going to talk about some IDS, IPS sensors, how they kind of work. We're going to go through some full packet capture stuff. We're going to pull the full PCAPs. We're going to actually look at them. And I'm going to show you how you can do this in your place, wherever that may be. Second, we're going to talk about empowering our users, right? So from where I started, doing PC support and running my own companies, fixing whatever it was, writing code, whatever it took, right, to get the job done. And today my role is completely different. But I'll tell you, I have a different view of the universe than a lot of people, because I've sat on all spectrums, and some of you may share that with me, and you may relate to what I'm kind of getting at here. And then lastly, I hope that I can maybe inspire you to share whatever it is that you know. Because as I talk to everybody here at DerbyCon, and I've been here for, done the last 5 of them, these talks are great, these people are great, and the best part about it is the people, right? I mean, look to your left, look to your right. I mean, this is the most powerful thing in this room, right, is us. And that sharing and standing on each other's shoulders and really learning. Because there's a few of us that are the really smart guys, and we put them out there and we share. And this is my ability to kind of say, look, I've done a whole lot, and people are like, you need to share more. So I'm like, okay, so here it goes, right? So this is my first thing at Derby for at least sharing. All right, so let's go deep. So just so you understand where I'm kind of going with the demo here, I have a bunch of little like makeups here in the beginning part of my demo. I basically have 2 Linux boxes. They're running Fedora Linux. I got a Windows 7 system. And then I'm using Security Onion as my basic sensor for monitoring for IDS, IPS. The reason why I picked Security Onion is you can go home and download this distro, right? It's an Ubuntu distro. It's got a whole bunch of security tools. Now what we're going to look at today is Snort and Bro, along with like NetSniff NG. NetSniff NG is the thing that does the full packet captures on the system. And that's how we're going to pull the PCAPs out. You can put this in line at the edge of your house or in your company. You can mirror port. And where you can do, and then the other things on there like ELSA, Squeal, CatMe, those are tools to basically look through them, and then CatMe is the ability to get things out. And then I added another utility that I wrote called Siggy Tools. It's just kind of a wrapper of a couple of different things to basically export the PCAP off of that, and you can find that out on the GitHub site. Again, a little bit more on Security Onion. You know, it's written by a guy named Doug Burks, so this is the whole part of like standing on, you know, other giant shoulders. Doug used to work at Mandiant, and now he just runs Security Onion all the time, right? It's a great product. It's not the end-all of end-all, but boy, it opens up a whole new world to everybody and really gives you a way to look at things. So show of hands, anybody know what Security Onion is? Just good? Sweet! Okay, hopefully you're all as big of a geek as I am. This will be good. Okay. Yes, that's the install going at like 900 times the speed, just in case. Taps, just because somebody mentioned it to me. Dual com, it's like $250 on the far left. Obviously, you can use a hub. You guys use the Security Onion, so you're probably already kind of familiar with most of this stuff. There's a whole lot of commercial things. They're in no particular order. I just copied and pasted off the internet. I'm not, you know, promoting anybody. And then another recommendation somebody made to me is apparently there's a TP-Link 8-port gigabit switch for $33 that actually has a managed interface that you can mirror port. All right. So real quick, for those who don't know, right, typical IDS configurations, right? So in everything I'm going to show, this is going to be a NIDS or a network-based intrusion detection system. There are other types of IDSs like HIDs, which are host-based intrusion detection systems. We're not going to talk of those, so we'll forget about those today. And the general kind of setup that you want to do with a network-based intrusion detection system is you kind of, or at least one that's passive, is to kind of put it behind the firewall, either at the switch, right behind your firewall. This is kind of their general way people do it. You can put them in front too if you want to capture different things. But generally you're going to see it behind the firewall. That switch is either going to be a tap, maybe a managed switch or something like that. The other side is there's an IPS, is an intrusion prevention system. These have the ability then to actually block the packets, hence the little ones and zeros getting stopped at the IDS device there. And you generally will put those, again, right behind the firewall, but you put them in line. They have rules to kind of block and deny things. These are more your commercial things. Right? So let's go ahead and get into some demos here. So I'm going to start the journey out with, like everybody does, with a little bit of a hello world type scenario, but in this case we're going to do it from the network perspective, which is ping, right? And I know it sounds really simple, but you're going to see kind of why I picked that in this case, right? So hopefully this shows up okay on these screens. And then so on the right-hand side, what you really have is you have one sensor, you have Snort and Bro monitoring on the two windows on the right. On the left-hand side, bottom left, you're going to see PC number 2. It's going to receive the pings. So I'm doing a TCP dump for protocol 1, which is ICMP. PC 1's then going to go ahead and do 3 pings to PC number 2. Right? So you see this guy's got the pings that are going, and then PC number 2, for everyone, it sees an echo request, and then you see an echo reply, right? Your standard thing. Now notice that Snort went ahead and threw out 3 different alerts, right? So for every ping, Snort said, hey, I see this, I see this, I see this. But notice Bro did not put in anything, right? Now Bro eventually will put something out there. It just takes a little bit for it to close the session, right? Now the interesting part is you really got to kind of ask yourself, you know, why, right? Is that happening in that way? Yeah, don't ask. So something we should all do, right, when we're thinking about security devices, it doesn't matter if it's an offensive tool or a defensive tool, right? We always kind of have to ask ourselves, you know, when it does whatever it does, right, we always want to know what is it doing for us and what is it not doing for us, right? So every time I talk to a vendor and they come in and they say, hey, my thing stops 100% of everything, and I go, 1, bull, right? And then 2, I love your stuff, now tell me what it doesn't do, right? Because especially as a CISO, and I'm sitting there, my job is to protect the entire organization, is I have to weigh everything on a basis of risk, right? So when I look at stuff, I want to know, well, what is it doing for me and what is it not doing for me? And if that vendor can't tell me what it doesn't do, then they don't know what they have, right? And I always tell them, go back, get your smartest guy that wrote the thing, bring him back to me, and then we'll have a conversation. And that's where we'll start, right? Because I already love your stuff. This is great. It's a matter of how much are you going to cover in my environment, right? Because there's always going to be a gap, right? That's the whole reason why we all have to buy insurance, right? Okay, so let's talk real quick about like the general detection methods of like how IDS IPS sensors kind of work. They all generally kind of fall into 3 categories, right? Signature based, statistical anomaly based, and then kind of protocol, right? So your signature based are things like snort. A lot of the commercial things do the same things, right? They basically have rules that say look for ABC followed by 1, 2, 3, and if I see it, do something, right? The anomaly based are watching your patterns of your traffic, looking for A talking to B, and then all of a sudden if it talks to E, it wants to throw an alert because something changed, right? And your protocol are kind of more like bro. So let's do that. Let's look at bro code real quick. And I'm not getting into it deep, and let's go look at a snort signature, and then we're going to kind of dig a little deeper here, right? So bro, unlike a signature, right, based system, bro understands the protocols. And what you're looking at here is this is actually probably the main piece of code for bro, right? So bro is this back-end engine. It understands actually the protocols that it kind of chews into. And in this case is a very, very simple example, right? And I just kind of blew up the pieces from something that writes out what's called the bro con log, which is the main connection log. Bro tracks everything, gets the authoritative truth to your network. Go look up Liam Randall and see about the 100 videos he's got on the internet on bro. And you'll notice here that, with these, connections, you're doing kind of like an if statement, right? So it's like up here you say, if transport equals TCP, go ahead and set these flags. Down here you can't see it, but it says if is UDP, do whatever, else, right, return other, right? So again, it's a programming language. So bro gives you this full capability to actually write code based upon the protocols that it sees. So you can actually do things like extract the file that it sees in stream, hash the file, look it up at VT, and then depending upon the result at VT, you can throw an alert, right? So you can do very complex functionality with bro because it allows you to do some programming, right? A little bit more on bro here is this is on Security Onion. All your bro logs are under /nsm/bro/logs current. They sit there for an hour. Bro rotates everything every hour and kind of compresses them and puts them off into a date timestamp directory. You'll see here, this is the bro con log. It shows your source, destination, IP ports, that kind of stuff, what kind of protocol. You also will see things like if it understands the protocol, right? So these are saying, hey, I see a UDP message here. It noticed that these are DNS. If it sees it and notice that the protocol is DNS, it will then write into the DNS log maybe further information such as the A record or the PTR record or something like that, right? So it's actually extracting the metadata from the information to kind of give you a little bit more analysis. And the things you would look in bro for is like, watch your HTTP streams, and you should only see HTTP protocols. But the funny part is you're going to see a whole bunch of things where bro goes, I don't know what the hell this is. Right? And it'll just mark them as blank, which should make you pay attention, right? Because most people don't run non-HTTP things over 80 or 443, which actually they do. Go look at, streaming video, right? So it'll be interesting if you go look at it. And then everything, of course, that bro thinks is weird is, well, in the weird log. Okay. So snort. So this is the ping example that I did. This is the actual snort rule that fires, but I wanted to kind of walk through it so you understand like why it fired. Because I'm going to show you a problem next, right? So this is the alert that fired, and then this is the real quick snort rule, and I just want to go over the parts in red, right? So what snort does is it says alert, right? It can drop and do other things with the things. If you put the snort in line, you can actually block stuff if you want. It looks for an ICMP message. It's looking for anything coming from the external network to our home network, which is anything on the RC private ranges. It'll spit out this message for any ICMP type 8. For those of you who don't know what that is, that's the echo request. So this doesn't fire on the reply, this fires on the request, right? And then inside the content, it's going to look for the hex values of 10, 11, 12, 13, 14, so on and so forth, right? Now, just so you're aware, the sensor that I'm running has 45,000 signatures on it. It has the Emerging Threats Pro subscription sitting on it. So this is the latest and greatest feed, right? And in there you can see here, we got like Microsoft Windows pings, we have Linux, Unix pings, all kinds of Windows ping stuff, right? But I'm gonna show you a problem that I'm dumbfounded by this, right? So let's go ahead and grab the snort rule in the PCAP because I just wanna kind of dig a little deeper so you can see what's in it. right? So on Security Onion, there's a web interface that's exposed, and from it you can get to some tools. So here we're going to go and log into what's called Squirt, and Squirt will kind of keep track of all of the snort signatures that kind of fire up. Again, this is part of Security Onion, so this is all right out of the box. Just install it, it's there, right? If you scroll down, you can see here's that ICMP info ping information. There's the actual rule that it fired. If you click on the link there, you can pivot to something else called ELSA, which is more of a database-driven interface for watching things. And then it kind of groups stuff either by, and you can do some queries here. The stuff's okay, right? There's some better tools out there, but for free, this stuff is rocking, right? From here, you can then pivot over to something called CapMe, and CapMe will try to actually export the PCAP for you. Now, in this case, CapMe doesn't work, right? And that's because CapMe kind of wants a source and destination port associated with the IP address. It doesn't handle ICMP messages very well. This was my driver a long time ago for why I wrote the SIGI tools, right? So let's go ahead and let's show you that piece of it, right? So if you go to the IP address, when you install SIGI tools, it just goes to /SIGI. On the same site, from here you go to this export PCAP, you put all of the same information in here, right? And I'm just going to grab the beginning time, ending times here, and put them in. And it'll tell you, the SIGI tools will tell you like how much data is actually on the sensor. It'll tell you how far back you can go, when you can go, that kind of stuff. There's some various parameters you can do, so you can put a starting time and just say run for like 60 seconds or 600 seconds, however you want to do it. You can then queue this. It'll then put the job down into a queue. It runs in the background like a daemon. There's some jobs that we run. We have some sensors that are in like the 25 terabytes or more. So if you run large jobs, they take a while. We generally will start the jobs, go to lunch, and then come back and look and see what we got, right? So if from here, you can go ahead and you can click on the little link, download the PCAP, and then we can open that up. So let's go ahead and open that into Wireshark because we downloaded it. And then we can go ahead and see here's the echo requests and echo replies, right? And this is all the communication going back and forth, right? And if you look down to the bottom here, you're going to see that 10, 11, 12, 13, 14, right? This is in the context in hex, right? Cool? Okay, so let's do one more, right? Let's do a Windows ping. So this is a Windows 7 box. I tried it with Windows 10 also, do the same thing, right? So what we're going to do, same thing as before, we're going to run snort, we're going to watch the alerts. On PC number 2, we're going to actually do the TCP dump. This time something just a little different, just to show you a small variance. If you use this -w command, it will write the file. Instead of sprinting it out to the screen, it'll actually put your PCAP to an actual file. And then on the Windows 7 box, as I scroll through other right commands here, we're going to ping Windows 7 to PC number 2. Now notice in this case, you got nothing, right? And you got to kind of ask yourself, like, why? Like we saw in the list, it supported Windows. It supported all kinds of Windows things, but apparently it doesn't pick up on this one, right? So while I'm here real quick, I'm going to explain why that didn't work. But real quick deviation. That TCP dump, here's a little trick for you. Take a picture of that. If you want to write it to a file and output it to the screen at the same time, you can take TCP dump, do the -w with a hyphen after it. It puts it out to standard out. You can then pipe it to T. T will then put it to a file, and then you can pipe it back to TCP dump, tell it with a -r, which is a replay, and that'll suck it back in and put it back to the screen. So now you can do both functions at the same time, right? Just kind of a small trick. I Googled it. It's pretty quick to find if you don't miss it here. Okay, so why is it not working, right? Because when I think about this, there's like 45,000 signatures. I just downloaded this yesterday. You would think that somebody would have in the last, I don't know, 4 or 5 years maybe made a rule that alerted on Windows 7 pinging opposed to just maybe Windows 95 or whatever the hell that stuff is, right? So let's go and look behind the scene a little bit here. So here's the PCAP from the second machine that we just saved, right? We're going to open this up and we're going to go look at the echo request and the echo reply. Now notice here what the hex values are, right? It's not 10, 11, 12, 13. So let's pull up our old rule, right? So this is the Unix rule, right? This is what it had, right? So this is one good reason for pulling out the PCAPs, which is Sometimes the alerts and the information it gives you isn't enough to quite figure out the example, but in this case, we want to write our own rules. So let's do that, right? So what we're going to do is we're going to copy what is over here. We're just going to do this real simple. We're going to go ahead and make another one, but we're just going to change the name so it spits out the correct message. And then what we're going to do, we're going to keep it type 8, which is again the echo request, right? And then we're going to go ahead and throw in the 61, so on and so forth, just matching exactly like this hex pattern is here. If it's between, these pipes, you use hex. If it was a string, you would just type it in, right? So now we're going to take this, we're going to throw this back on the sensor. If you modify rules on Security Onion, you put them under the, etsy NSM rules / local.rules, and then you'll go and run rule update, which is what's happening here real quick. And then it'll go ahead and restart snort. Their videos, I should just fast forward, but it's kind of fun to watch. All right, so let's do it again, right? So this is our Windows 7 box. There's snort listening on the right. So this is our Windows 7 box. We're now going to go ahead and ping from one side to the other. And we should see our alerts, right? So there's 1, 2, 3, and 4, because Windows always does 4 pings, right? Pretty cool, right? Hopefully you guys do that on your own. Now, real quick comment here, right? Which is, and this is kind of will be one of my points on the end, which is you can't always trust what's out there, right? The beauty, at least, to snort and the open source stuff is all the rules are there for you to see. I can tell you, we run a whole lot of corporate and commercial stuff. You don't always know what's in them, right? So it's kind of like, trust us. I'm like, well, okay, well, I trust you, but like when I go ahead and look at this, I was a bit shocked that this wasn't there, to be really honest with you, right? I mean, I don't dig into this thing every day. It's not my daily thing I do, but I was a bit shocked that that wasn't there. So if I would love, I was talking to some other folks in the crowd here over the last couple of days, I would love to maybe set up or talk to the ET folks and see if we can, as a community, try to make a better pool of this kind of stuff, because and my understanding is that there's only a few people working on this stuff, and if all of us do a little bit, maybe it'll make it better for everybody, right? Now, I realize this is just ping, but there's got to be a lot of things that are also missing. I mean, if they're missing ping, I don't know. That's just my opinion. Okay. So let's do some story time. Right? So we're all sitting in our comfy chairs. We're all sitting here. We show up to work. We're going to do some, we're all analysts in the company, right? And we load up our machine. We pull up our sensor, and we're watching our logs. Hopefully it's a better interface than this. And then all of a sudden, bam, right? We get this alert, right? And it says, oh my God, right? We have a Trojan. It's an IRC NIC change on non-standard port, right? Sounds really bad, right? And any of you guys that look at this kind of stuff, you probably see this all day long. So we look at this and we say, okay, well, whoever this is at 192.168.15.143 is going to this non-standard port, right? Because IRC runs on 6667 to 6669. And so we look at this and we say, okay, well, let's get some context around this. So let's follow this super handy dandy link out to emerging threats, and let's see what they have to tell me, because they obviously wrote the rule. So we can pull up a browser, we can go out to the page, and we can, okay. Well, it gives me the snort rule at least, which doesn't help me a lot, right? It tells me maybe why it fired, but sure doesn't tell me any more context around if it's good or bad or whatnot. So let's see, all right, so let's go figure out what else we can do, right? So let's go back into Security Onion. Let's go to the standard web page. Let's go into Squirt. We'll go see if we can find the actual same message. You only get one guess what the password is. Okay. So here we are. We find the IRC NIC change, right? So again, there's our snort rule. There's our handy link that tells us almost nothing or what the snort rule is. Here you'll see each communication path that happens in Squirt. And if you kind of expand it, you'll see the actual, individual session. You can click on that event ID right there. And what it's going to do is that's another way to pivot over to CAPME. Now this time, notice that CAPME did actually export the PCAP for you. And wonderfully, it put it in this nice display, right? So this is very similar to Wireshark if you do TCP follow, which we'll do in a second. And blue sessions are your client talking to the outside, red is server coming back. And so this is kind of a handy way of getting to the data really quickly. At the top of the link, you can click it and you can download the PCAP just like it did there. All right. And so just from a different perspective, I'm going to show you how to do the same thing with SIGI tools, right? So I'm going to hit close. I'm going to go back to CapMe because I want the start, end times, and the addresses. I'm going to go back over to SIGI tools, but I'm going to do something a little different here with this one, right? So CapMe is going to give you the individual session of that move, but what if I want to do like a broader search, right? What if I want to look at everything that system did to that port? Because maybe what I want to see is, well, what other context is in this story, right? Because we want to know a little bit more, right? So I'm just going to copy the source, start time, end time, and then what I'm going to do is I'm just going to put in the source address and the destination address without the ports, right? So CapMe wants the ports, right? Remember, so it's going to give you the individual session. With the SIGI tools, it'll let you do any request you want at all, right? To that extent, too, you can even do like a post request to it. So if you have a SIM, which is what kind of we do in our world, we even take like our firewall logs. So our network guys, they call us and they're like, hey, we want to do a packet capture or something, right? So instead of they're sitting over the keyboard and, you're on the phone with the other guy and you're like, okay, ready? Now. Oh, no, I mean now, right? I mean, how many people do this when they cap it patch, right? It's a nightmare. Just go put the sensor and let it just watch everything. Go to the firewall logs, right-click, export, and you get everything. It'll dump everything for that session, right? So here real quick, this is what it went ahead, it grabbed all the files, it downloaded it, and it's blowing by, I apologize. But what it was showing you is that it pulled up something totally different than what you saw with the CapMe, right? And that's because it's seeing the whole message and it was looking at some other communication that machine was doing. And now what I'm doing in the video here is I'm going back and I'm going to put in the finer detail of the source and destination ports, and you're going to get exactly the same thing that CapMe gave you, right? They're both good tools. They just have, again, limits, right? So you always want to understand how far they go, what they can do, and what they can't do for you. Because in crunch time, hopefully none of you had to, deal with that pucker factor 10 moment. But when you do, you want to know where to go, when to go, and how to get it as quick as possible. And you want to be able to see it from every angle, right? So, okay, so we downloaded the PCAP. We're going to look inside of it. We're going to right-click. We're going to say follow TCP stream, which is what everybody does. And again, just like the other screen before, you see here's the NIC anonymous. This is how the snort rule fired. That's what it saw, right? And so we're going to scroll through this, and we're going to put some context around what we saw in here. We're going to try to determine, is this really a bot? Is this really being evil? Or is it okay? It looks like it's kind of streaming. Oh, wait, no. No, look, it's ESPN. It really is evil, so. I'm not a sports guy. Only if I play them. Cool? Okay, so just to show you a little bit more here, if you go back to Squirt will, if you drill down into it, show you how it fired the rule, right? So if you find that rule, you find one of the sessions, and you expand it, and then you hit the little RT on the side there. This is really handy, right? It will automatically drill down. These guys did a heck of a job on building these things. I mean, hands down to them, right? I mean, this stuff is free. This is pretty amazing, right? But again, if you were looking at this alone, right, what do? Right? Send your help desk guys out to re-image the PC or go hunt for malware or run a scan for 3 or 4 hours with some AV software that they're never going to find anything because there really was never anything evil there to begin with, right? So as security analysts, we got to think about this kind of stuff, and we got to take a little extra moment, and if we can optimize how we do this process, right, we can cut down the next guy's job, that much better, right? So it's always about making the next guy's job easier. So just kind of some lessons learned, right? So these are just some very high level, and there's probably a much longer list than this, but just from kind of the talk, right? So first off is that, IDS and IPS devices only trigger on events if there's a rule for that event, right? So that is for snort, Circata, that kind of stuff, right? Now, Bro's a little different. Bro will track every single event that goes on, and it will create you a connection log of everything, right? It is an authoritative truth of what happens on your network. But remember that the things that are firing on rules, they only go if something actually bad happens, or somebody wrote a rule for it. It doesn't always have to be bad. An alert does not always mean that traffic made it to its destination. Right? I have another demo in here if I had time to show you. You can fire things off and hit ports that aren't valid, and it'll still fire the rule. Because again, some of these rules are so simply written, they just look for certain patterns. That it was ABC followed by 1, 2, 3, yep, fire it off. Right? So you can be hunting things down that never actually make it to where they need to go. Right? Unless the rules are written a little more complicated or put a little bit more logic into them, you don't. They're not always indicative that something actually happened. Right? And then that whole point on they're not indicative of what's telling you, right? Our alert, as we saw, is this is a Trojan in our network. It's calling an IRC channel. Must be a command and control, right? We always go right for the evil first. Well, not necessarily the case, right? It's literally, and I actually found the site, literally it was just a guy listening to the radio and they used IRC as a chat, right? Now, I'm pretty old, so I did a whole lot on IRC. I totally get what it is, right? Some people today go, well, I don't know what that is, right? So, okay. Because we're talking PCAP tools, I just want to throw this out there. TCP dump, you can use it to do all kinds of crazy stuff, right? I mean, here I'm just doing simple packet captures and whatnot, but it's a great analyst tool. There is a SANS course. If you guys go take it, I took it. It was really fun. Mike Poor did a great job. And we spent 2 days literally just pounding through TCP dump and getting in and actually reading every hex byte and figuring out and deciphering it by hand without Wireshark, right? Which to me, being a total dork, loved it, right? TCP rewrite allows you to rewrite your packet. So this, and even in some of these examples here, or some of the other ones, you can take packets from one network, pull them over here, you can rewrite them, so you can say anything on the 10.da-da-da-da whatever network, I want it to all be 192. It'll rewrite the packet for you, fix all this checksums, and then you can replay it, right? Which then goes down to the 2 apps down, which is TCP replay, which actually allows you to suck in and replay packets on the network, right? So now you can take your PCAPs, maybe something didn't alert, but you at least got the packet capture for it. You can go write your signature rules and you can fire it off multiple times. You don't have to sit around and wait for the bad guys to attack again or wait for something to happen, right? So you can just take the same thing and keep replaying it back. You can also, by the way, use Snort and Bro and bring in PCAPs and it'll analyze it for you directly. Merge cap is something that Sigi Tools uses on the backside. So if the way NetSniff-NG stores all the files, it keeps all your little packet captures in a bunch of little files, and you designate during the install how big you want that to be. I think the default's like 150 megs. I think on my little VM here, it's like I made like 10 megs. But the point is like in our universe where you have these really huge sensors, we're watching a lot of data. Within 1 second, we could crush through like 10 or 1,150 meg files, right? And so if I'm just looking for like a 60-second window, I could be looking across all kinds of PCAPs when I want to go and export that. Well, what MergeCap will do, what Sigi Tools does is it kind of automates the process for you. And all it does is it goes down and it runs a TCP filter, it replays them and says, I'm only looking for this based upon a Berkeley packet filter, which is a way that you can kind of say this source, this destination. If you don't know it, look it up. But the idea then is you can bring this stuff in and then you can save them out in a file and then you can merge them all together in one stream and now you have one PCAP, which is your whole communication. You don't have like 50 little teeny tiny PCAPs that you got to look at individually, right? And then Foremost, and there's some other tools that do this. Foremost is actually like a carving tool. It'll actually reach into the PCAP and export like executables or other things and pull things out of it. There's some other versions of this, but Foremost is one of the ones that's been around for a while. Just because I run stuff on Windows, because I have a different type of job. Most of you probably do Linux and Macs, and I get it. So, Wireshark, if you don't know it, learn it, live it, breathe it. It's awesome, right? There's all kinds of stuff here that you can do with it. I found this other really cool tool called Wire Edit. I was a bit shocked by this. This thing was pretty awesome. It's a what you see, what you get packet capture editor, because I was looking for a way to take some of my actual PCAPs and change some of the information inside besides the source destination address. I wanted to actually change the content inside of them, like change domain names to Contoso or whatever it is, demo.com. The Wire Edit will let you do that. It is pretty amazing. Network Miner is another tool that actually lives on Security Onion, and you can download it for Windows and other operating systems. You can feed it a PCAP, and it'll kind of show you the session information, it'll break things out for you, give you the files and all that kind of stuff on the thing. Be careful with that on Windows, because it will export all of the malicious binaries if they are in there, and you don't want to double click. Just saying. Okay, so let's empower our users, right? So I'm going to switch just a little bit here and do a little bit of soapbox. In sitting in the role that I sit in, I see kind of a unique way of looking at the world because I'm the ultra dork, but I also sit and I deal with all the executives and I deal with my end users and I deal with other larger problems on a daily basis. And one of the things that I kind of find is that as a community and as an industry, right, I don't think we communicate very well to our end users. I don't think the vendors that don't communicate to very us. My example, is the emerging threat kind of post, right? What's the context around that, right? It would be great if whoever found that said, hey, these are the kind of botnets or these are the kind of things that do this, right? To give me more research. I mean, it was like a dead end. Like, here you go, somebody's talking on an IRC channel, right? But it's a Trojan. They're saying it's bad, right? So it's kind of like, we need to get that message out. We need to kind of work with ourselves and each other a little bit more to get this message to kind of educate and share a little bit better. And with that being said, I did create a tool that helps with phishing, so I'm going to steer this a little bit towards phishing. And I did this with a very good friend of mine, a gentleman by the name of Dr. Jeffrey A. Martin. Jeffrey has been in IT for like 35 years. He kind of got out a while ago, and now he's doing like psychology and neuroscience, and he's been to Harvard. He kind of got away from IT, and now he just kind of does research on like why the brain does the things that it does. But it's always nice to talk to fellow people that look at the world in a little different way. And we came up with this tool around how to kind of educate our users and help them with phishing. But we always start with this kind of a principle, right? Which is a problem well stated is a problem half solved, right? Because you got to know what you're trying to solve before you're trying to get there, right? Think of the goal in mind, well, I'm Joe, so I would always go back to my childhood, right? And knowing is half the battle, right? I mean, that's right. So when we think about phishing, right, what do we all do, right? We buy appliances, we put them at our gateways, we block certain extensions that we don't let them kind of come through. We put on SPF records, DKIM, we do antivirus, we do sandboxing. We hire phishing companies to phish our people, fool our people into clicking things, and then we give them training after the fact, right? And then we do our annual, hey, don't click on stuff, that kind of stuff. We also go out to the internet. If you go search and you look for things, these are my favorite bad examples of things like, don't click on any hyperlink in any email, because that's practical. Verify that the HTTPS is on your address bar, because that has everything to do with phishing. Obviously keep your antivirus up to date, anti-spyware, I get all that. My favorite one is install and maintain the reliable firewall, because if we could just stop mail from flowing altogether, it would stop the phishing problem. And might as well just unplug the systems, which is the next rate to that one. Some of the better kind of comments, right, and these are all true, right, is watch for heightened or urgent requests, that hyper, go click on me now. You look for spelling mistakes, although they're getting better at, fixing those kind of things, right? Unfamiliar greetings, inconsistencies in email addresses, which every user misses, right? And then, the one you always watch for is be wary of suspicious or shady attachments, kind of like that one. M&M folks, there you go. Yeah. Look for the reply to address. I can't tell you how many people are fooled by the spoofed in as, hey, your executive wants you to go do this, and then they reply to some other thing at yahoo.com, right? And then obviously don't do login credentials or whatever. And when in doubt, we always tell our users forward it to IT, right? Now this poses a new problem, right? Essentially what we're doing is there's one of me, or let's say a crew of me, right? Because some of my crew's in the back there. And we're basically telling, there's 70,000 plus people in my company, right? So I'm telling 70,000 people, oh, hey, just send your mail to me. I'll look at it for you, right? Like that's how I really need to spend my day, right? And this is why the problem exists. And so what do, right? They say, well, hey, I received a message. Is it phishing or not? And if they say no, they go what? They click on it, right? And then what do? We mitigate malware on the bottom, right? And if they do think it's phishing, then they go and they follow that path over to the right, and they say, well, let's just send it to IT. And then IT goes and does a whole bunch of work. And then we go and try to hunt down and find our users to tell them what it is we found. And by that point in time, they've already clicked on it. We mitigate malware, right? So, and I know I'm being a little bit, flippant in a way, but there's some truth there, right? Otherwise, it wouldn't be there. But what do we do, right? So we get these things, and we all kind of do the same thing, right? Now, maybe your list is a little different than my list, if this is the short one, right? But on attachments, if there's an attachment there, we'll take it out, we'll hash that attachment, we'll look it up at VirusTotal, right? Maybe if it's an Office document type or whatever, we'll tear it apart and look at it and try to see if there's any scripts or other types of, malicious thing in it. We might run it through a sandbox, right? Or we'll reverse engineer something. If it's got a URL, we'll do the common sense thing, like, well, where did it come from? If it came from, UPS and it goes back to like, Jim's, fitness shop, it's probably not UPS, right? And we just kind of use common sense in a way, right? And we always have to find that user, right? And depending upon how big your organization is, that's sometimes tough. But there's got to be a better way, right? And this is what my solution to that better way is, right? So it's something that we created, Jeffrey and I created, we called Scanfish. Today it's in alpha testing. If you go to scanfish.com or scanfish.io, eventually we will put it out there. We're going to make this available, at least a free version of it, to kind of help people, because I look at people like my mom who always call me, because that's the other user, and she's always, hey, is this bad? I'm like, you already clicked on it, so it doesn't matter, kind of a deal. So, but the goal of Scanfish, right, was to educate my end users, right, is to do something a little different than all the companies are doing now, and it's also to empower my team and IT in a way. Right? Because let's face it, right? We get phishing in, and then it infects our end users, and I'm telling you, those gateways don't stop 100% of everything, right? So you will always end up with stuff in your inbox, right? And then you're stuck with this problem, and if you have a very large environment, is the time between, okay, we know it started happening at this time, my users show up to the office at this time, and then they have another 4.5 hours to click on things before I can go run that Microsoft PowerShell to delete that message out of everybody's mailbox, and hopefully I caught them all, right? I mean, it's a nightmare, and there's nothing really great to solve this. So this hopefully will help with that, right? It also gives you kind of real-time feedback, right? So the way that it does it is in this case, it's an Outlook add-in. It adds a couple of buttons. We call the buttons the help button. It's the human explanation of learned pattern. The idea here is to try to teach the end user a little bit about what they're seeing, to give them a little bit more of a control or context around the email and why we're checking it, right? And so the way that I validated this is, of course, I write it all in my super geek speak, and then I give it to my wife, and she goes, what the hell does that mean? And then it takes me 4 or 5 hours to explain to her IT stuff. And then she goes, yeah, you're doing this so wrong. And then she rewrites it, right? I should have worn my other shirt, which says, I don't need Google, I have my wife, right? So then what happens here is that little icon will change colors based upon the threat level, right? So if it's green, you're generally good. If it's red, it's automatically bad, we should just throw it away. And so a lot of this stuff is configurable. And then inside of every message, because we really, really want you to kind of get the point, is we put a bar over at the top of the message. And you'll see this in a second. But the idea here is that depending upon the severity, and then you can click on the little see more link and it'll pull up another window. And I think the best way to demonstrate this is I actually have a working demo. So what you see here, so this is actually my inbox as of last night, right? So I spoofed these little emails, because you can spoof anything you want. So this is Mr. Evil sending me a message, right? Of course, they send me this nice survey.doc file. It's not a doc file, it's a PE file, right? Which is amazing that I actually got it through the mail gateway, because it is an executable. And it says, hey, and obviously the link here is someevilplace.com, right? So we'd all IT guys go, yeah, just delete. The users probably already clicked on this thing, filled out the survey, sent it to their buddies. So if you click on the link here, though, what it does, it pulls up this little window. This is the help context, and then the interface might change over the next few months, but the concept here is it's kind of showing you like all the mail servers that it went through. So it takes your header information, it tries to translate it for you, tell you what's good, what's bad, tells you kind of how many times you've talked to somebody. It does actually learn who you talk to, what the normal patterns are, so it knows what's weird or what's different. And then down at the bottom for every attachment, it's going to automatically hash the file for you. And in this case, it's going to tell you, like, for example, that this is a PE file, right? So it says the attached file contains a program or executable, and it kind of says it's bad, right? And it shouldn't be that way. It's a doc, right? So like, why is this a PE? And you click on it, you go to VT, and it doesn't know what it is. Trust me, this thing is bad, right? I actually set myself something really evil just to see if it'd block it, right? Nobody knows that it's evil yet. And so what you can do here is you can take this and you can do like the default. Okay, we know this is bad enough. It's screamed at us. Let's forward this over to IT. We send it to IT. There's a whole server side to this piece, right, that you can go to. And when I actually implemented Yara rules, or a form of them, right, so that you can do Yara type rules back on every single endpoint. And so in this case, what I'm going to do is I'm going to take the PE one that I had set that made the alert level to high, and I'm going to set it to critical. Now what it's going to do is Scanfish is automatically going to know, hey, if something is critical, just throw it away, because the end user really shouldn't have it, right? So I said this is critical, I save it on the server, and then we're gonna go back to the client. We're just gonna sit and we're gonna wait a minute. And then the client checks into the server every periodically and kind of says, hey, do you have any new rules for me, something update, just kind of, you know, keep it like a heartbeat. And what you'll see will happen is that middle message is just gonna magically disappear, right? So we're gonna give it a minute because this is pretty much real time, right? And so as that client will check in, it'll reanalyze that message and bam, there it goes, it's gone, right? And that's using Yara to kind of look at the actual attachment. Now it's not writing the attachments out, so I'm not doing all these crazy things. I'm actually looking at it in the PST file, right? Now here's the example of the inbox, right? So now we wrote this rule because this campaign is still going on, right? And I haven't quite figured out how to stop it, but I at least know what some of the signatures are. And again, I can use Yara, so I can do some crazy stuff. So here it is coming in. This is the same message. Scamfish is going to look at it, and it's going to go, oh, that was bad. It's going to throw it away automatically, right? The end user didn't even have to open it, right? So a couple of points right this, right? So what's the point, right? The point here is, and the whole kind of concept for why I did this, right? And actually, I kind of been thinking about this idea for more than a year now. It's taken me the last year to get to this point from the development point of view. You know, I will tell you, I was sitting out on the tables literally at DerbyCon because my certificate expired on Friday, right? Because that's when I bought the certificate for this to set this thing up, right? But the whole point around this is that we need to get better at working with our end users, and we need to get better at working ourselves, right? Because again, 70,000 people are sending me emails saying, Joe, will you please check this, right? If I can get 1% of them to be smarter, right? I've already got a larger IT staff now looking at email in a better way than I've ever imagined ever affording anywhere, right? So if you can just educate them just a little bit. I mean, I realize that you're still going to have the same people, and trust me, they're really smart people, because they are, and they just click on things, because it's just what they do, right? I mean, I've got attorneys. I had an attorney the other day do it, and very, very smart person, right? It's just what we do. It's just human nature. We see it, we want to get in, we want to get our work done, we want to move, 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 move. And that's when mistakes happen, right? It just happens, right? But the whole point here is that we got to get better at communicating. Right? We got to get better at helping our users. We got to come up with new ways to teach each other, and we got to have new ways to teach, you know, people, right? I mean, just one more little example here, right, before I'm almost out of time, is I wanted to download a file the other day, right? I wanted, you know, portable tools, right? You do a little USB stick, right? I wanted a little color picker off the screen so I could make things match in my little demo here, and Symantec was nice enough to say, hey, this thing's weird. But even Symantec goes, but I don't know what to do. Our stuff is inconclusive. And I'm like, now I think to myself, like, well, is that really a useful message or not? I'm like, look, you're the AV vendor. You're telling me it's inconclusive and you want me to make the decision? Because I was pretty confident in my decision when I wanted to download to begin with. Now you're making me nervous, right? So, you know, I mean, we got to think about how we're communicating to each other, right? And I mean, this goes for every vendor and us. Right? I mean, at least if you go back to like some really old like error messages, this one was just straight up honest, right? Like, look, there's no help, you're screwed, have a good day, right? And that's a decade old, right? You know, this is at least a little more fun, right? I always love the Unix messages, right? This one's just Windows loves cookies. Just wants to know when it's going to get his cookie. So that's pretty much my talk. Hopefully that was useful and made it worth your while. I do appreciate your time. If you have any questions, feel free to email me. This inbox gets spammed like there is no tomorrow, so put something like, hey, I saw you at DerbyCon or something like that. That makes you not look like a robot. And I will do my best to respond to you. I'm happy to answer any questions. I'm a little hard of hearing, so you have to super speak up. But other than that, thank you very much. Try to be safe getting home. And go DerbyCon. Sir? Yep. So, yeah, I mean, this is the dilemma always, right? I mean, and now I'm not saying that my tool is a replacement for all those other tools, right? Defense in depth, right? It's just another layer to try to help, right? It's that additional piece. Because I look at it with my team, and I sit there like, I don't know you, but I know on a regular basis we deal with yep, my gateway didn't stop something. I know I have at least one, maybe 100 people that have this evil thing sitting in their inbox, and I got no way of mitigating it other than calling my mails team and saying, can you please run this PowerShell script? Can you please delete it? I know it's going to take a while, and there's just going to be some collateral damage in between, right? So one of the reasons for putting the YAR rules in there and making it go back and do this client server piece was so that we could reach back out and help things, right? So even if the end users didn't use the tool and they didn't click and learn anything from it at all, it at least gave me the ability to go and do things at their end. You can actually go and turn all the buttons off and just use it like an engine for IT. Right? There's a whole client configuration at the server side, and it calls home and says, how do you want me to behave? You can just say, get rid of all the buttons, just help IT, right? So it just gives you the ability to reach out and touch somebody no matter where they are, right? You also get things, by the way, I can't get into all, I mean, I could talk for a long time what it all does. It actually tracks, like, if the user did click on it, what they did they remove it out, did they even open it? Right, and you can get some analytics out of it of the, did they read it, did they not read it? Like 100 came in, but only 50 of them actually looked at it. Yeah, thank you. Say again? For the enterprise, there will be. For the free, we want to give it away because we want basically people to help us make it better and support it, right? There is the concept, right? So all the stuff is cloud-based, right? So the concept is either go enterprise, right? You could do it that way, or you could do it almost like a managed service. So if you if you say you could do consulting for a bunch of little companies, and they're never they don't have IT staff, right? You're gonna manage it for them. There is a way to then group smaller companies under a larger company, and you can manage things for them, right? And you can turn things on or off. Yep. No problem. Thank you. Down.
Can you hear me?
It's okay.
Check, check, check. Can you hear me?
Alrighty. Hi, everybody. How's it going? Y'all are here to squat for the closing ceremonies, right? Sweet. They're going to kick you out. All right. My name is Todd. We're going to do a little bit of talking about threat hunting, I hope. I am not an expert. I will throw that out right now, here and there. Full disclosure, yay! We're all done, right? You're still here. What's wrong with you people? Like I said, name is Todd. I am not a threat hunter. I work for a global organization, and they say I'm an engineer. I'm not quite sure what I'm supposed to be doing with that job because I actually manage an MSSP half the time, so go them. I have accomplishments in my life, which includes submitting a CFP, which got me a free ticket to this amazing event this weekend, and I am on par with Ben 10 on height, though tragically I did just check Twitter. And somebody he has found is shorter than him. Here, that is, looks like they're an adult, so I don't have a claim to that one just yet. Also, it would be great if I can find a unicorn gun that fires rainbow poo out of its ass end. Totally awesome. So, another slide for the beginning. We're going to do threat hunting, like I said. A couple of items. Try and explain threat hunting. Figure out what do we need to do some threat hunting. Threat hunting, yay. Has anybody kind of picked up a standard, it's a good word here, I'm losing my mind all of a sudden, theme for DerbyCon so far? It's been a lot about hunting. I'll stop saying hunting now because if anybody's drinking while I say hunting, they're going to be wasted at this point in time. So explain me the threat hunting. Why your sock sucks? Well, threat hunting is really not a sock activity from what I've gathered so far. It's more of a human-driven thing that if the sock can't find it, well, you need to go hunt for it. And really, you sit and you think about it. If you expect your sock to go hunting for you, you're basically trying to live in insanity. The sock does its thing and you expect it to do something different. Yay! Go Albert. So, what the flip is, threat hunting. Threat hunting is basically a human-led activity where you go looking through your environment for the bad stuff that has gotten through. Case in point, if you have some weird-looking DNS, DHCP things out there, you might want to investigate it. There might be something super nasty in your network already. It really does rely on the concept of assuming breach. You figure you've already been screwed. Somebody's in your network. They're doing happy, fun things that you don't want them to do. You need to go find it. You need to kill it. Bad. Vendors like to talk a lot about threat hunting at times. It smells wonderful occasionally. They will misconstrue the concept, so please, if you are talking to any vendors about threat hunting, you keep in mind some of the things, the resources I can provide to you today as you're discussing with them in order to see through the crap. So, first off, what do we need to do? What some of the things we need to do to try and go threat hunting? We can just jump right in. Yay, bears! See, I tied this back to the title. Seriously, I'm going to try and do this again. Realistically, you need to have some kind of maturity in your security operations organization. If you don't know what's in your environment, you don't know what's happening, threat hunting is going to be almost a waste of time. You're going to be sitting there looking for all the nasty stuff, and all you're going to find is day-to-day activities that are perfectly normal. Or you're just going to be searching for known bad stuff that for some reason you aren't finding in the first place. Your AV sucks. Your SOC team sucks. Everybody sucks. You're not educating people, and it just sucks. Yay. Good thing to do about threat hunting is assign somebody to go after it, to run the threat hunt program that is just tenacious as hell. They won't quit. Werewolves are cool. They listen to music all day long while they're just punching on the keyboards. Don't you love werewolves? Is everybody falling asleep? Okay. Learn to love some data. You need to have data to threat hunt. Otherwise, you can't do anything. It's like staring at a computer screen all day. Shit, that's what we do already. Never mind. Also, you want to know your network. If you understand your network very heavily, you understand what packets are running around, what services are running, what you expect kind of protocols to be running. It will help quite a lot. Otherwise, again, you'll be chasing a freaking ghost all day long. Like, oh my God, there's DNS running around and I'm looking up Quad A records. Yeah, that can happen. If you're aware that that happens, but you know that you shouldn't be looking up any TXT records, if you find yourself with 2 or 3 boxes that are doing 2,000 or 3,000 TXT lookups, you might want to go check them out. They might be having small problems. So threat hunting is a bit of a circle. It goes around and around and around and around and around, just like Rob Schneider does in his big circle. See? Circles. It's not a triangle. Triangles are pointy. They will break you. They will hurt you. They will stab you in the eye. Circles, not triangles. So there's a couple of different threat hunting loops that are available out there. I like Squirrel's. This is where I grabbed the picture from. Squirrel's loop is 4 steps, hypothesis, kind of building an idea of what's going on, what do I want to look for in my environment, really built on taking in some statistical analysis, threat intel, and a couple other things like that. Next up, you start investigating. You bring in all the data, more data, 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 data. Yay, data. So you've got all your data, you start parsing through your data, you're staring at the screens, again, all day long, staring screens. Finally, if you find some anomaly, something weird sitting out there, you might have found the bad guy, or maybe not. You just may learn something odd about your environment that is perfectly normal. In those instances where you do find out the bad guy, and you suddenly like, yay, I found the bad guy, I'm going to kill him, yay! Okay, great. Treat it like a rumor after the fact and get everybody else to know about it as quick as possible. That way you can help build the community and make people smarter, and nobody else will find the bad guys. Down with the bad guys. So, dig in a little bit about the hypothesis. Hold, please. The hypothesis. There we go. So, hypothesis is basically an educated guess. It can derive from a variety of places. For example, the TXT record I talked about just a few seconds ago. If you're getting some intelligence that some particular actor, threat group or something is starting to use TXT records, probably they're pulling down some base 64 encoded stuff from some random domain or whatnot. They're putting it back together, deobfuscating it, and then all of a sudden you have a nice, wonderful PowerShell command that's pulling down additional malware and making life hell. That's an idea for a hypothesis. Start looking for that stuff, right? Again, everybody's asleep. Nobody's shaking their head. You do not agree with me. Grand. Nifty little story. That is the AT&T Global Network Operations Center. Got an opportunity to go there earlier this year. That place is freaking nifty. They got a lot of screens. So imagine how much sports is to watch there. Is mentioning sports a bad thing with this crowd? No. Good. So a couple of interesting graphs that they showed. They actually showed a few pictures where they're looking at the variety of high-level protocols going around the environment and their network, TCP, UDP, ICMP, whatever other Ps you want to add out there. And then they showed a screenshot from September of 2001, whenever 9/11 happened, and they saw a significant drop. Those are the kind of statistical analysis you can perform as you see changes in your day-to-day feeds in your network and all the protocols and whatnot going across the wire. You can see those changes and start thinking something weird is happening and start going after it. Do all the threading of the things. It is primarily human-led. You need to have a person there behind the keyboard driving this thing. Tools help. They really do. You can automate a lot of stuff with threat hunting with the tools, but there's got to be a person involved at some point in time, probably to click the button, I would assume, but there's other things that a person can do. Tools aren't the smartest thing in the world. We still do not have Skynet, thank God. So, yay, tools. Let's try and throw this one here. Better situational awareness. Yay, Army things have gone through. Help make legendary hypothesis. So if you are, again, aware of your network, know what's going on and whatnot, and you've got all this intel coming in, you do some analysis and whatnot, the more you're aware of everything, the better your hypothesis can be, and then boom, you have beaten Halo on legendary level. On to the investigation step. Let's get dirty. Yes. Everybody knows what happens when you have really dirty computers, right? Dust bunnies. Yay. And your eyes do get crossed up unless you're sitting like that from 1950 or some shit. So again, exploring your data sets supports your hypothesis. Again, back to that DNS thing. If you're looking for DNS things, who gives a shit about all the web records, right? Who cares? It doesn't matter because we're looking for DNS things. Try not to get sidetracked. We all have ADHD. Yes, it's okay. Just try and stay a little focused. Complete data set is a bit of a requirement. If you have holes in your data set, you may not find all the bad people, and that presents a bit of a problem, right? Everybody's again shaking their head because you're all awake. And use the tools available to you, whatever you've got. EDR things, modeling tools, Skynet, maybe. Obviously Skynet wants to kill us all, but that's okay, right? We'd die anyways. Uncovering things. So you've taken your hypothesis, you've been doing your investigation, you found an anomaly that does not belong in the place, you found the bad guy, and we have a title that has been completed. Yay! So seriously, bear hunts, bad guys, you got it. Cool. Maybe with this discovery you can start identifying new TTPs, the tactics, techniques, and procedures. You could also call it triple TP. Add some tools in there. I heard a talk earlier where they like the words attack pattern. I don't care. Pick your word, whatever you want to do. But you find the new things. You could potentially find new lateral movements, new evacuation techniques, etc., etc. Ooh, maybe you find the new way that nobody else thinks about that people have gotten in and are starting to exfiltrate data. Yay! Stop it. Figure out how it works, and then inform and enrich. Recycling, you found bad things. Take it somewhere so that you can start using it again. Primary thing, if you've hunted it today, don't hunt it tomorrow. Stick it back into your hunting tool, your hunting process, so you don't have to find it again. Give everything more protein, bigger tools, bigger tools, bigger tools. Woo, woo, woo! I love Jimbo, he's so funny. So, feed it back into the detection tools. This might be a bit of a challenge, obviously. I think this was brought up earlier in the con where some tools don't have a way to accept new feeds. You found new bad stuff. Great. I want to give it to my AV so they'll find it. AV doesn't care. Okay, great. I want to give it to my IDS IPS. They don't give a shit either. Well, damn, where can I stick it? Ooh, firewall, firewall. Nope, sorry, go away. So that might be a space where we as a community can start making pushes and get things changed and get the more awesome going. Sharing is caring. You get an ILC, you get ILCs, everybody gets ILCs, yay! Y'all are so happy, I tell you what. Or if you're into an Oprah Winfrey show, you all get high, yay! All right, recap again. It's a circle, it's not pointy, pointy hurts your eyeballs. It goes around and around and around and around and around. I have now completed a loop between this slide to previous slide, so you see two halo things, woohoo! After the hunt, start your next one. Don't sit and wait around wasting your time. Hunt for the next bad thing. Find more stuff. Give more ILCs. Share, share, share. Go Oprah. Keep hunting. Keep learning about your environment. Keep finding all the new bad guys. Remember, you need to understand what your normal is in your environment. If you don't know normal, you can't figure out all the super bad stuff. So as you find new normal, feed that into your knowledge base. You know some jerk over in the network team is suddenly running a random Samba server to do a CMDB. Great! Mark that on your stuff. Okay, I want to say a few things about the kill chain. Kill chain's a little important to hunting because some steps of the kill chain do apply here. Those three, control, execute, maintain, exfiltration, those are some spots in which you can start finding the bad stuff. Hunting before this, who cares? That's not in your environment, most likely. You want to check your environment. Did you know Microsoft has a kill chain as well? It's like a roller coaster. Whee! They do have the blog right there. It talks about their kill chain. They've broken the picture up into multiple slides. There's this pretty slide here, and then there's a slide here, and they include a roller coaster on the slide. And this roller coaster has this guy in the front. What the? It's the devil! Seriously, see? He's got horns. So Microsoft is introducing us to the devil. Yay. So, we've gone through the threat hunting. We talked a little bit about kill chain. Now we need to talk about continuing and growing old with this stuff. Threat hunting is not something you just do today and you stop. You keep going, you keep doing, you keep improving your process, and you keep getting more cool stuff to go with it, right? Squirrel has got a maturity program as well. Apologies for just calling out Squirrel a lot here. I do have some resources towards the end that hopefully won't include so much squirrely things. This involves a lot of keeping up with your data, having more data, more data, more data, more data, more data, and automating a lot of things. It's simple. Look at that. 2 bullets every step. Bullet, 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 bullet. Yay. Again, more data, more knowledge. You go through threat hunting, you learn more about your environment. Yay. You're expanding your knowledge base. Keep on going. Make it your own. What I mean by that is the threat hunting process that everybody's going to go through is probably going to be unique. If you build a program, make it your own. Tailor it to your environment and what you need to do, what you need to take care of, etc., etc., etc. Do as much automation as you can. Automatically being able to use your cool tools in order to do some of the threat hunting steps for you is great. It helps a lot. Moves you right along. Tape measures. Probably everybody in here has to report on some kind of metric, right? I see a wobble. I saw one head nod. I see a couple left. Yeah, you guys are just totally ready for closing ceremonies. Do not care. So being able to identify where you can build up some metrics, show that you're actually being successful, or show the executive leadership what you're doing with this new cool program, because it's totally freaking awesome. Things like, hey, we did a threat hunt and we found out the network team is doing something stupid. Again, CMDB on a Samba server. Let's mark that down. We'll check, yay. Or here's the number of hunts we've executed. Here's the number of bad things we found. Here's more ILCs where you got an ILC, you get an ILC, everybody gets an ILC. And weed. Okay, so whole point here, circle processes, hunting in circles, going around and around and around and around. Hunt with a goal in mind. What do you want to do? You really want to try and find all the bad guys? Do you want to mostly learn more about your network? Kind of like learning about my network. ILCs are cool and awesome and Oprah-fied and stuff. Do keep in mind it's not limited to massive organizations with huge teams and huge budgets. I don't threat hunt like I said, but hopefully one day I can start playing with it. I do work for a pretty large organization. It is global. I am a team of 1. Seriously, there was an org chart that was released recently. It had a box above it, 2 boxes beside, and there was me in the middle, and everything else was vacant. Yay, we can do this together. Hunt with priority, hunt with intention. If you're going to hunt, don't stop hunting. Just keep on hunting. If you start going down one rabbit hole, just persist like a son of a bitch going down it the whole way to the end of it. Automation rocks. Hunting still requires a human. You've got to have some person to sit there and read all the cool things coming in, all the more data as you get, data, etc., etc., etc. And last but not least, who here likes, my mind, seriously, I just had a brain fart. Shit, what is that? Gaming marathons. Summer games done quickly, awesome games done quickly. Anybody? Oh, man. This makes absolutely no sense to anyone. So in a particular game, Final Fantasy VI, you can manipulate the background, and some people have discovered that if you set the controls just right, you can make this big bird thing look like a giant demon called the Demon Chocobo. If you decide to go look at any of these cool marathons, then vote for good taste. Don't vote for that damn bird. Summer games done quickly, awesome games done quickly. Go look it up. You'll be fine. So, I just racked through that frickin' thing in like 20 minutes or so. To reiterate, I'm not an expert. Go read, go play, go do something else, go read some stuff. I've got a a whole bunch of resources I've been trying to collect this year as preparation for this talk because, again, I was just wanting to get a free ticket. Yay me. So there's a place I stuck stuff for you to try and read. Hopefully it will be beneficial to you. And so in conclusion, hunt in circles, hunt lots, hunt all day long, give it back. IOCs for everyone, go Oprah. Any questions? Yes, sir. It's a good question. If you didn't hear him, the question was, where do you start documenting everything? I don't know, to be honest with you. I'm sure there's probably resources out there. I'll see if I can find one to stick it on there for you later. What do you think? Perfect. Yes. Cool. Anybody else? Yes, sir. Yeah, certainly. Certainly. Anything else? None? Cool. Awesome. Thank y'all very much. Appreciate you coming.